All right. Hello. It's been a while again. Uh, Christmas was a bit busier than I expected, but Happy New Year. Welcome to part 24. Yeah, it's part 24. Past the 3 month mark now. I started this the 30th of September 2022. It's now the 4th of January 2023. So yeah, more than 3 months of this. This being, I'm writing a WebAssembly interpreter in Ruby. I'm doing that to have fun. I'm doing it to demystify WebAssembly for myself and maybe for you. And I'm doing it to share how I do it. Hello, Chris. Happy New Year. Thank you for joining us. Remind myself of what my principles here are supposed to be. Ostensibly, my principles are as follows. I'm more interested in having fun than making something that is fully functional. At the point where this stops being fun, I will probably stop doing it. I want to write code that's correct, even if that means it's not particularly fast. I want to write code that's clear, even if that means it's not particularly clever. I'm doing it in pure Ruby. I'm doing it with no dependencies. We've come this far. I'm probably going to stick to that now. So, as always, before I get into the code, let's start with a brief retrospective of what happened last time. If I can cast my mind back to the slightly younger, slightly healthier version of me that existed before Christmas. So last time I finally started dealing with the fact that structured instructions, so that's like block and loop and if, then, else, can have a function type. So that means that blocks consume values as well as produce them. So you can annotate any block by saying this block consumes 3 values, and 2 of them are 32-bit integers and one of them is a 64-bit float. And it produces a 64-bit float or whatever. Unfortunately, doing that required more work on the parser, which I'm kind of sick of working on now, but a lot of the features I'm adding do require more work in the parser, so that's how it's going to be. And the reason for that is because of the way that type uses, which is what a block type is, can also generate new type definitions. So if a type use is referring to a type that doesn't currently have a definition in the current module, then we sort of dynamically generate a new type definition, and then we can, having synthesized a type definition in the identifier context, then we can figure out what its index is and insert that into the AST. So it's a little bit complicated. And the existence of block types means that whole rigmarole of having to synthesize new type definitions, if there isn't already one for the type that you are trying to use, that previously could only happen at the top level of a module, because the only places where I saw function types were in function definitions, which can't be arbitrarily nested. They have to be at the top level. And so I could collect all of the type definitions just by looking at all of the function definitions at the top level. But now that those block types can appear on any expression, there are now many more places where the identifier context can be updated during parsing. So I had to do quite a lot of faff to make it so that during arbitrary expression parsing, it was possible for these new type defs to be synthesized and the index to them to be inserted into the AST, and to make sure that those type definitions were retained. When we left that, whatever the lexical scope was where that type definition got generated, most of the time when you're leaving a lexical scope, you would want to just throw away whatever extended identifier context you had generated, but that's not what we do for type definitions, because they sort of live at the sort of global level at the top level module. So anyway, so that's what I did last time. The parser is a bit of a mess as a result of that. I had to just kind of bodge it around to get it working. But on the other hand, it means that I did get the if block.wast and the block.wast tests parsing, which I feel very happy about because it feels like concrete progress. I think I would have been extremely demoralizing to have spent all of that time and energy sorting out all of that identifier context rubbish and type definitions and not even make any test pass. But in the end, I did get those two files, all of the assertions that I support are parsing. So that's great. I did end on a little bit of a cliffhanger last time because the block type still isn't being treated correctly for loops. So that's probably an obvious place for me to pick up the thread this time. I think that's all I've got to say about that. But that's my retrospective of what I worked on last time, and even just talking through it now is actually helping to very slowly sort of impart some momentum to the flywheel in my brain, so that's good. A couple more things. Firstly, I said last time that I'd built up quite a large backlog of like tidying that I needed to do, and if anything, I only added to that backlog in my previous stream. So the backlog is definitely still there, and it's not getting any smaller. I mean, as I just mentioned, the code around the identifier context has become messier in the abstract syntax parser because now it can be modified, updated by the parsing of an arbitrary expression. And in addition to that, I've still got the high level problem that I'm cloning the whole S expression of the module in order to sort of parse it once to extract the initial identifier context, and then I parse it again to build the AST rather than just taking a single pass over the input. And that problem has existed for a while, and I don't like it, and I haven't fixed it yet. So again, I kind of doubt that I'm going to be able to do very much of that tidying up this time, but I do want to keep reminding myself that it needs to be done, so I don't allow it to languish for too long. So if I manage to get some test passing this time, then I might permit myself a little bit of sort of therapeutic refactoring to see if I can. I've got a very long laundry list of small fixes, so I might just work off some of those. And finally, the release version of Ruby 3.2 came out on Christmas Day, as expected, which is, well, firstly, that's wonderful. And secondly, it means that we've got access to the with method on the data class, since Ufuk smuggled that into Ruby's main branch, like right almost at the stroke of midnight before Ruby got released. So again, if I manage to make some tangible progress, then as a tree, I might see if I can make use of that. I'm pretty sure there are a couple of places where I'm sort of instantiating a new data class, and then I'm just calling to hash on an existing one, and then sort of clobbering one or more of the keys with new values. So that's what the with method does. So I might be able to use that in a couple of places. Or maybe I could have a go with YJIT. I still haven't really looked at that. So I suppose we'll see how I get on. Chris asks, I saw Ruby 3.2 also has a supported WebAssembly version. Do you think you'll be able to run it in your interpreter at some point? Yeah, a couple of people have asked that actually, and I'll say to you, Chris, what I said to them, which is that has been, since the beginning, that's been a sort of stealth goal of mine, because I think it would be extremely funny to be able to, well, the thing is, it's definitely a stretch goal, because in order to run Ruby compiled to WebAssembly in this WebAssembly interpreter I'm writing, I would not only have to pass all of the WebAssembly specs, I would also have to implement WASI as well, which is like an operating system interface, like libc for WebAssembly. So, well, actually, that's not a very good description of it, is it? It's not really like libc. It's more like, POSIX, I suppose. So I think it would be very funny to be able to do that. I would really like to be able to do it. And it's one of the things that made me interested in doing this in the first place, was the realization that soon it was going to be possible to run Ruby on a WebAssembly runtime, and it would therefore be quite funny to be able to run Ruby on a WebAssembly runtime that itself was written in Ruby. And then you could like arbitrarily nest them, right? Then you could run the WebAssembly runtime on the Ruby that was running inside the WebAssembly runtime, and so on. So I would love to do that. It feels quite a long way away at the moment. I mean, I'm conscious that at the moment I haven't even really, I haven't like convincingly run a single WebAssembly program yet. That's not entirely true because, of course, the tests themselves are WebAssembly programs. But like, it just occurred to me recently that, well, what occurred to me recently is I don't quite have enough machinery yet to be able to say that you can run a WebAssembly program. So it's maybe quite a long way off, I suppose, is what I'm trying to say. But it does remind me that it would be nice to be, it'd be nice if the repo for this thing had like a README that showed you how you could run a basic WebAssembly program with it. Because at the moment, well, firstly, there is no README. And secondly, if I was going to write a README right now, like the only thing this thing can do is like run the tests, which is the only thing that I care about at this stage. But for someone who was just checking it out and wanted to see what it did, it would be nice if they could just run a sort of, add 1 and 2 together and get 3, or find out what the 9 factorial is or something. Chris asked, does the reference interpreter come with some example simple programs? I'm not sure. That's a good question, though. Let's have a quick look, because I am actually quite curious about that. Let me get a web browser. So github.com WebAssembly spec. So yeah, here's the reference interpreter. Doesn't really seem to. I mean, well, what I mean is there's not a directory here called examples. Yeah, there's no obvious example programs here, right? I mean, maybe in text. No, that's the stuff that deals with parsing and stuff. Yeah, I can't see any obvious examples. I mean, I'm sure there are loads of there are tons of like basic WebAssembly tutorials on the web where people have very simple programs. I mean, the problem is, that's not a problem exactly, but like part of the challenge of this is that at least without WASI, there isn't like, what WebAssembly lets you do is define a module that's got some functions in it that you can invoke. And all that those functions can do is compute a result. So that makes it rather difficult to even conceive of the idea of like a standalone WebAssembly program. WebAssembly modules are designed to be sort of exposed to some kind of host program that's written in JavaScript or in Ruby or whatever. And then your JavaScript code, calls into the WebAssembly to compute something expensive, and then it gets the result back. And then it's JavaScript's job or Ruby's job to like print that value to the screen or draw it onto a canvas element or whatever it is that it's going to do. So even the notion of like running a simple WebAssembly program, I'm not really sure what that would look like. But it is something, I'm actually going to add it to this list because I think, think about what running an example program might look like. I think modules might have a default function in them. I'm not sure about that. I think there might be a way inside a WebAssembly module to say like, this is like the main function or the start function or whatever. But then I don't know what the semantics of that are. Like what happens if you run the start function. I mean, if it's got access to WASI and you've imported all of, if you've got the ability to print stuff to the console or draw graphics to the screen or open a network socket or whatever, then fine, it can go nuts. But I don't really know what you can do apart from return value. So I'm going to think about that. Yes, Chris, as you say, Turing machines aren't very useful. The thing that Simon Peyton Jones says that, if you've got a pure, like in Haskell or something, if you've got a pure program or computer program, then when you run it, all that it does is that the box gets hot. So I'm kind of at my WebAssembly interpreter is currently at the box gets hot stage of sophistication, but it would be nice to have an example program that does more than makes the box get hot. So we'll see how far I can get with that. Okay, well, on that bombshell, let's see where I am at the moment. I assume that all the tests are passing and stuff like that. Of course, good to verify that. Now, what I did last time was in like a moment of pleading with my future self, I moved these two things I could do next maybe to the top of the list. And I think what this was about was trying to get loop.wast passing. So why don't I add loop to this? Because I think that loop.wast is failing at the moment. And so let me try and narrate my lukewarm understanding of what's going on. So, okay, length mismatch. All right, I don't know exactly what's going on there, but clearly loop.wast is failing successfully as expected. So let's say add loop.wast to pending tests. Wow, Git GC kicked off there. That was exciting. I don't remember it having done that before. This repository has either become old enough or large enough that that's necessary. I actually don't know how often it does that. Maybe it's after 90 days. I don't know. Anyway, so the deal is that previously on this project, I got block types working, sort of. So we can now parse them successfully. So it's supposed to be a visual medium, isn't it? Let's look at, let's look at loop.wast. That's the thing I'm going to try and get working. So, so here, for example, this is a block type, and this is saying that, and this is only a result. So this doesn't have any, this block doesn't have any arguments, but it produces three results: a 32-bit in, a 64-bit in, and a 32-bit in. So we can now, or I've always been able to parse this because I had a special case for the when there was just a result there. Let's see if we can find one that has a probably a bit further down. I'm looking for a loop that has some parameters. So this is referring to, yeah, okay. So these type uses here are referring to these type definitions up here. So that's kind of good enough for what I want to talk about, because you can see, for example, block sig4 is the type that, the function type that takes three parameters of 32-bit float, a 32-bit integer, a 64-bit float, and a 32-bit integer. And then it returns a 32-bit integer, a 64-bit float, and a 32-bit integer. So that's the type of this loop. So we can now parse this, and I believe that, yeah, because the tests are all passing, I guess that we're doing the right thing operationally for normal blocks. So literally the block instruction like this, and for conditionals. So if you've got if then else, you can also annotate it with a block type like this. But we're not doing the right thing for loops, and I think that's to do with, let me just pull up the spec a second. So there's, I think it's probably an execution control instructions. So there's some information here about what to do when you enter. So here, when you enter a block, right? So here's a block, it's got a block type, it's got a sequence of instructions. So this is the body of the block effectively, and then it's got an end. So we say expand this block type. So that means just figure out what type it is. There's some there's some boring information there about the fact that this could be an index into the type definitions, or it actually could be an inline type under certain circumstances. So we need this sort of normalizing function here that turns this block type into something that is just, you know, a one of these function types that's got 0 or more parameters and 0 or more result types, essentially. So we do that. And then there's some faff about the label and some faff about validation, which we can ignore. But here's the important bit. Pop the values val m from the stack. So m is the number of inputs to the block, the number of parameters. So we pop that many values from the stack. And then we enter the block. Well, we enter this block specifically. We enter a block that is all of the values and then all of the instructions. So last time I spent a bit of time puzzling over this, where I was like, well, why do we pop the values from the stack and then effectively synthesize a new block body that consists of, firstly, the instructions to push all of those values back onto the stack and then do the block body? That's silly. It feels like a no-op. And what I said at the time is that maybe this is important for loops, because you can see for loops, it's basically the same business, and for if, it's basically the same business. In fact, for if, really, it just says, what does it say? Oh, yeah, okay, this just tests the conditional, and then it says, well, just evaluate, effectively synthesize an AST that's just a regular block. So if here just sort of delegates to whatever the operational semantics of block is, and loop does almost exactly the same thing. The only difference here is that here it says let L be the label whose continuation is the end of the block. So what that means is L is where we're going to jump to if there's a break, if there's a branch, sorry, inside the block, whereas here it says L is the label whose continuation is the start of the loop, because if we branch inside a loop, we have to jump to the beginning of it rather than the end, using the Zeta maneuver of using redo in Ruby. So that's sort of all set up now. And this stuff all works. I haven't actually implemented it this way. In fact, I think what I did, this was one of the branch handler. This was one of the last changes I made. Yeah, this was it. So I've sort of accounted for this. I'm not sure I realized this is what I was doing last time, actually, but when I look back over the commits, I realized that this is what I was doing, is that when we go into a block, which is what this kind of with branch handler is, so when we go into some kind of chunk of code that we might want to be able to jump out of, whenever we jump out of a block body, we have to unwind the stack to the sort of the state it was in before we entered the block, essentially. And I think that's what this is all about. This is saying before we enter the block, we arrange. So let's say, like in this case, the loop is supposed to consume 3 arguments, 2 32-bit ints and a 64-bit float. What this is saying, regardless of whether it's a block or a loop, is that like before we even start evaluating the body, so before we enter the block, we pop those from the stack. So what that means is that whenever we jump out of that block, whenever we finish the execution of that block, we are in a situation where those values have been popped off the stack. And so I think that's the significance of this, is that when we enter the block and we essentially push those values back onto the stack again, that's so that they're on the other side of that kind of block entry boundary, so that when we jump out, we're not in a situation where we have those values still on the stack. Now, the way that I've dealt with that here is by doing, well, can I be more selective than that? Is by doing this. So I've said, this is before we start evaluating the body of the block. I've said, we don't actually need to remember the contents of the stack. We just need to remember how high it is, because the block, the validation, which I haven't implemented yet, but a valid WebAssembly program, the code inside a block can't pop more stuff off the stack than it can't consume anything from the stack from its environment other than the things that it's declared as being parameters. So we don't have to worry about the contents of the block like eating away into the existing contents of the stack. So we don't need to save the old stack, but what we do need to do is remember how tall it was. And then there's this thing here where I'm subtracting. So if the stack was height 6 initially, I'm saying, well, let's remember that it was height 6, but then let's subtract however many values the block is supposed to be consuming, so that when we restore the stack to this height, which I think we do, yeah, down here, you know, stack.pop, stack.length minus stack height, that's saying like, well, let's make sure that if there's any extra stuff on the stack that was pushed there by the block, let's make sure that we throw it away and return the stack to its original height. So this is trying to compute the initial height of the stack by sort of artificially subtracting the number of parameters that the block has. Whereas what this is saying is like, well, you don't need to do it artificially. What you need to do is actually pop those values off the stack, and then inside the block, you push them back on again, essentially. So that's how I've currently compensated for it. And that's totally fine, because this is just a no-op. Popping the values off the stack and then pushing them back onto the stack again leaves the stack in exactly the same state as if you'd done nothing. And so as long as when the stack is rewound, when the block finishes, it's rewound to the correct height, then everything's fine, right? So I could get away with not actually manipulating the stack at this point, but just remembering the correct height that we want to be able to restore it to when we exit the block. However, and again, I think I realized this at the time, but I chose not to actually deal with it, this technique doesn't work for loops because the body executes multiple times. So this is saying L is going to be the label that basically is labeling the start of the loop. And then what we're saying is that we enter the block that we enter, the labeled block, is first push all of these parameters onto the stack and then execute the block body. And then if you branch, I don't know why I keep saying break, if you branch inside the loop body, then you're branching up to the top and these values get pushed onto the stack again. So I think that's why the test is failing. And I haven't investigated it at all, but this is just my mental model of what's going wrong, is that I think if the loop executes 3 times, then on the first and the second and the third iteration of the loop, we have to begin by pushing whatever values we popped off at the beginning here, we have to push them anew onto the top of the stack so that the instructions inside the loop body can reconsume them again. And I'm not doing that because I'm just leaving the stack alone. So that means that constraint that I mentioned before, the validation tells you that the body of the loop, for example, can't chew its way through stuff on the stack that it shouldn't be able to, doesn't hold in this case, because I'm allowing the loop body to consume. If this was a loop that was supposed to have 3 parameters, the body of the loop can consume 3 values from the stack, and then on its next iteration, it can then consume 3 more values from the stack, and then another 3, and then another 3. So I'm supposed to be replenishing those parameters on the top of the operand stack each time around the loop, and I'm not doing that. So I think that's why it's not working. Oh, hi, Kevin. Kevin Newton is here. Kevin says, CRuby does this popping by moving its stack pointer but leaving the values in the stack. So the block still sees the values because the stack is untouched. Right. And that is pretty analogous to what I'm trying to do here, I think. I mean, effectively, I'm calling this stack height, but this is effectively my stack pointer, right? Like this is saying where is, in the array that is my stack, where is the top of it? And so that's essentially what I'm doing, is moving my stack pointer, but not modifying the stack. But I don't think I can get away with that for loops. Now, does that in any way, is that interpretation in any way substantiated by the error that we're seeing here? Because I've got, I mean, this length mismatch. So, okay, what is this? I mean, basically, I think maybe there is a temptation to just fix my implementation to do exactly what the specification says, right? And then maybe the test will pass, and then maybe I can move on with my life. So that is quite tempting. On the other hand, it feels a bit, I understand why they've done this from a sort of formal perspective. It makes total sense to, if you're trying to formally define this sort of small step evaluation relation and like the operational semantics of a programming language, this is exactly the kind of thing that you want to do, right? Is like, what am I trying to say? What I'm trying to say is that they're not at all worried about whether this is, efficient or anything. They're just trying to find the simplest thing that can possibly work that has the properties that they want. And what this is really saying is, remember the top n values from the stack, and then each time the loop body, each time you branch back to the start of the loop, sort of restore those, because the body will have consumed them. But they're just saying it in this sort of, this unnecessarily verbose way, not in terms of the words written here, but in terms of like what the abstract machine ends up doing here is popping m values from the top of the stack and then synthesizing the instructions to push m values onto the top of the stack. And it feels a bit laborious for what it's actually trying to achieve, but it makes total sense here. So I'm just thinking out loud about whether I want to just recreate that. And maybe I just should, because it'll make the test pass. And then it's a separate question of like, well, can I think of a more clever way of doing it? Kevin is saying you could potentially change your pop and push functions to be kind of a moving window. Oh, I see what you mean, I think. Kind of a moving window. I'm not sure I do see what you mean, because, I mean, it makes sense that, when you pop, you could just move the stack pointer. Oh, you're saying such that only the top frame actually pushes. Yeah, that's what I was going to, you said otherwise a push overwrites a value. That's where I was going with that sentence. It's like, it's fine for pop, but it's not fine for push, right? Because you need to be able to restore those values. If the block consumes all of the parameters and then it, pushes some other junk, we need to be able to rewind for the next iteration of the loop. We need to be able to not only rewind the stack to its initial state, but then we need to restore those. We need to restore those three original or m original values on the top of the stack. I mean, as I'm talking this out, it's making me more tempted to just do the simple thing, to basically to replicate the operational semantics here for the sake of making the test pass. And then once the test is passing, then I can try and get creative with like alternative implementation strategies. But I think the realization that I'm not actually doing this properly is the most important thing. So Kevin's saying, presumably a function return value should pop off its stack and then write at the parent frame stack pointer. Honestly, just push for each loop. Lol. Yeah. I mean, this is simple. Everything you're saying is making a lot of sense, Kevin. It's making me realize that the main thing it's making me realize is that at the moment, I don't have activation records. Like, I think I am going to need something like a stack frame. He says with a quavering voice. It's just making me realize how far away I am from actually something that's actually sensible here. Like, at the moment, I don't have a reified activation record. I don't have a data structure that is the stack frame. I'm just using Ruby's call stack. I think maybe I can, just running this experiment forward in my head, I can see that this would be way easier to achieve. I think I'm sort of slowly coming to the same realization that you're trying to explain to me, Kevin, is that like this whole thing would be much easier to arrange if I had like an actual representation of a stack frame, and at the moment I don't. So I think what I'm going to do for now is to try and get it working. You know, when I say I'm sort of using the Ruby call stack, I guess this is an example of that, where it's like, well, where's this information being stored? And the answer is not in the WebAssembly, not in a data structure in the WebAssembly interpreter. It's just being stored in the Ruby call stack in a local variable. So I think instead of doing this, I could just pop these parameters off the stack and store them in a local variable, and then here, before I yield, I could push them onto the stack, right? And then I think I would get the behavior I want. And then I think there's going to be a separate reckoning, which may be forced by the semantics of WebAssembly, of me actually introducing stack frames. Because I suppose that, I mean, this makes it sound like I've thought it through, and I really haven't, but like, the way this is panning out right now, I'm really only doing things that I'm being forced to do by the tests, right? And so I'm loath to introduce something like I've got stack frames until I get to a point where I don't have any choice, because I can't implement the semantics of the language properly without them. And right now, because of the one-to-one correspondence between Ruby stack frames and WebAssembly sort of function activations, I can sort of get away with just storing everything in the Ruby call stack. So I'm gonna see how far I can go with that. Kevin says 100% you will need a stack frame. Block should probably push a frame, 2 stacks basically. Yeah, and I mean that's exactly what this operational semantics says, although it's not exactly what it says, because they have this single unified stack, which is just for the purposes of making the. So yeah, they do have activation records, but these activation records just get pushed onto the same stack as everything else, I believe. So yeah, they essentially do have 3 interleaved stacks, but they've smushed them all into a single data structure, whereas I think I don't have very much incentive to do that. Oh, you said it, including arguments. Where does it say that? Oh yeah, here. Holds the value of its locals, including arguments. Yeah. So this is, yeah. So at the moment, this is manifest in, when I invoke a function, I do this. So again, like the activation record is the stack frame for the invocation of this invoke function method in Ruby, and that's where we save the argument values. But yes, at some stage I'm probably going to need, I should have an actual activation record that this gets written into and a stack that it gets pushed onto, but because that stack coincides with the lifetime of the function that's being invoked, I actually don't need one at the moment. So yeah, it's all a bit of a rip-off at the moment. Anyway, what was I trying to do? What I was trying to do was understand this error. Just because I want to... Why do I want to understand this error? Because I just said a load of crap, right? And I don't know whether that load of crap is actually correct. So let's find out whether reality has a well-known my opinion bias. So this is complaining here. So it's saying length mismatch, given 1, expected 2. Right. So this does actually support my interpretation, right? Because like I was saying, this is what this is complaining about, and this is actually a nice feature of pattern matching, isn't it? That I wanted to pop 2 values off the stack, and in a valid WebAssembly program, which I'm trusting that all of these all of these tests that I currently know how to execute are valid, there should always be, you know, it shouldn't be possible for you to reach a binary operation without it being statically evident that there are going to be at least two values on the stack, right? So in the program, this is a valid thing to do, but the exception is telling me that actually at this point there was only one thing on the stack. So I guess this, you know, slightly naughtily, if you try to pop two things off of an array in Ruby and there aren't two things, it just gives you a potentially smaller array containing 1 or 0 things. But fortunately, this pattern match has caught that. And I think that does support my hypothesis that what's happening is that the subsequent iterations of the loop are sort of chewing through too much of the stack. So let's just see what happens if I make the change that I was talking about. So in fact, let's focus on something that I know is working. So, because actually I did have to, so it was this correctly account for block parameter arity in branch handler. This was the thing where I had to subtract this to get it passing. I think this was to get if.west working actually. Let's just check that. So if I won't actually bother doing it at the Git level, but if I sort of effectively revert that change, yeah. So the reason I'm doing this is because I want to kind of, under this parsing test, I sort of want to refactor this code in a way that I hope will support, the currently failing test. So what I mean by that is, what do I want to do? I think what I want to do is, do I currently have something that's like, I've got parameter names, so could this be like parameter values? And what did I do in invoke function? Yeah, argument values. I mean, parameter values is a bit of a weird name, isn't it? Because parameters, they're effectively arguments. I'm going to call them argument values for a pedantic reason. I feel like parameter values doesn't sit right with me. I'm sorry. Okay, so what I want to do here is pop off the right number of, so effectively like that is my, that's, by popping them off, I have now adjusted the stack. I've now subtracted, if the block had 3 parameters, then popping 3 things off the stack has now reduced the height of the stack by 3. But the problem is that this yield here that is going to actually run the block body is now going to fail because these argument values are now gone. So yeah, that doesn't work. You know, this is the same kind of problem. This was something that was trying to, I'm sure that this was a similar thing, line 205, that's trying to pop stuff off the stack. Oh, I don't know why that's, oh, it's 333. Sorry, I don't know why I did that. Yeah, same problem, right? So that's the failure I was expecting, is that now there's not enough, the block can't find the stuff on the stack that it was expecting to find because I've popped it off before the block got a chance to get it. Why is this called saved operands? That's so weird. I think that should really be result values. Saved operands is quite a bad name. So that's something for me to fix in a minute. Oh, this is another thing I should have fixed by now. Look, I've got a to-do for this. I'm sorry, I know I'm jumping all around all over the place, but I know I've got a to-do for this. Use identifier context to replace symbolic labels with integers. Like I've got this, I'm sort of switching on the type here because the label could be a string or it could be an integer, but that's another job for the abstract syntax parser to do, is to resolve all of those labels so that I don't need this duplication here. I can just assume that it's always an integer. So I think this code is all still correct. I mean, really, I just need to make sure that here, before I yield, I push those values back onto the stack. So I think this is sort of, from the point of view of a block that can only execute a maximum of once, I think this is not a behavior change. Like, it's a no-op both ways, but this way around, we're just doing more busy work with the stack where we're popping things off of it, and then we're measuring the length, and then we're pushing things back onto it. So I think that this test should still be passing, and I think block.wash should still be passing. However, I think the important difference of having moved this push inside, because this catch here is the block that could ultimately run multiple times because of the zeta maneuver here, redo if redo on branch. So if I redo here, then this thing is going to run again, and then we'll push the argument values again. So I'm really hoping that at the very least this is going to give us a different error. Oh no, it's given us the same error. That's very disappointing. So this was invoke name params break. Yeah, so that looks like it's exactly the same point. Well, I'm sad about that. Okay, so maybe I need to actually think about what redo is doing here. And also maybe I should actually look at what the code is that we're executing here, because I haven't really paid any attention to. Okay, good. There's only one invocation of this. So everything up until this point has passed okay. So obviously loops basically work. I don't know what the fuss is about, but clearly this params break one doesn't work properly. So what's going on here? So for whatever reason, this one was working okay. Param break. But this one isn't. So what does this do? We call it with 12. What's this? Does this section have a comment that says what it's trying to test? No. Okay. So this loop takes two parameters, which are going to be 1 and 2. In fact, why don't I'll do the thing where I just copy this spec test core loop.wast. Copy that here. And then this looks like it doesn't use any of the, looks like it doesn't use any of the other stuff. Oh, hold on. Did I do that, haven't I? Okay, so there's the module definition. And then, okay, so I think this is the, this is our sort of minimal test case. Yeah. Okay, so, I mean, am I even thinking about this right? Like, what does redo even do? But yeah, this clearly wasn't enough to make it magically work. Okay, so the theory here is that we start executing this with a single value on the stack, the 12. Well, I mean, that gets popped off and put into a local. Oh, hold on. This is not an argument. This is the expected result. I'm sorry. My brain is not working properly. I was like, this function doesn't have any parameters. The arguments would go in after the name of the function here, but this is the expected result. So the expected result is 12. So we don't call this with any arguments. It's just got a single local called x. We push 1 and 2 onto the stack, and then we begin this loop, which is going to consume the 1 and the 2, and then it's going to return a result which is supposed to be 12. So we add the 1 and the 2 together. Then this is basically local.set. So it's going to set x to be 3, but it's also going to push that t also pushes the result onto the stack. So now we're going to have 3 in x and 3 on the top of the stack, and then we're pushing 3 onto the stack, and then we're getting x again. So now we've got 3 and 3 and 3, and we've got, what's this const 3 for? Oh dear. This is a less than. What is going on here? I'm sorry. I know I should just be able to read this, but I don't understand what this loop body is supposed to do. I mean, there's a drop here, so maybe the idea is that it's just supposed to be garbage. That this 3 is here just to be annoying. Yeah, I'm not sure I fully understand what's going on here. I don't understand why we're doing local t here and then we're doing local get. Maybe it is, maybe it's just literally to have this garbage value here that then gets dropped. And then if we, yeah, okay, this does kind of make sense now. Okay, so, all right. I think maybe what's going on here is that we add these two values together. We store them in X. Hold on. And this makes me realize that I have maybe not correctly understood the operational semantics of a loop, because nothing changes. Like, my assumption was that, well, the reason why I made this assumption was because I thought it's what this said, that we push the same values onto the stack each time. But I don't understand how this loop works in that case. Because if each time we're just restoring the 1 and the 2 on the top of the stack, then the result of this add is always going to be the same. This is always going to be storing the same value into X and leaving the same value on the stack, i.e. 3. This is always going to be pushing a 3. This is always going to be getting 3 out of X. This comparison of is 10 less than 3 is always going to fail. Well, sorry. This comparison of whether 3 is less than 10 is always going to succeed, and then it's going to branch back to the top of the loop here. So this makes me think that I haven't correctly understood how loops are supposed to work. Let's just have a look at this. Control instructions. Block, loop, and if are structured instructions, blah, blah, blah. A structured instruction can consume input and produce output on the operand stack according to its annotated block type. Does it say anything about loops? Each structure control instruction introduces an implicit label. Okay, this doesn't really say anything useful. Well, let's read this. Branch instructions come in several flavors, blah, blah, blah. Taking a branch unwinds the operand stack up to the height where the targeted structured control instruction was entered. However, branches may additionally consume operands themselves, which they push back on the operand stack after unwinding. Forward branches require operands according to the output of the targeted block's type, i.e. represent the values produced by the terminated block. Backward branches require operands according to the input of the targeted block's type, i.e. represent the values consumed by the restarted block. So I think I may have misread this. And in hindsight, my interpretation didn't make very much sense. But I just misread what it meant by with label L here. I think we have to do this. I think we have to do this nonsense every iteration. So I think these, and this makes way more sense than what I was saying before. I think these provide the sort of the initial inputs. And that explains what this is for. Right. Okay. I am now finally sort of understanding what this is talking about. So what's going on? Yeah, okay. I mean, it's my fault. I didn't understand what this was saying. I jumped to conclusions about what this meant. And in hindsight, it wasn't a sensible conclusion to jump to. So it was just me being stupid. what is actually supposed to happen in this program is that our initial input is 1 and 2. So for the first iteration of this loop, we read 1 and 2. So we add those two together, we consume them from the stack, we add them together, we get 3. And then we store that in this local variable x, and we also leave that value on the stack. So we leave 3 on the stack. And then we push another 3 onto the stack. And then this is going to be the input next time around. So is the sum of 1 and 2 and 3. So next time around, we're going to be adding 3 and 3. And then the inputs are going to be 6 and 3. And then the next time around, we're going to be adding 6 and 3. And then the inputs for the next time are going to be 9 and 3. And so we're eventually going to get to the point. So this get the value of x, get 10 and compare them is sort of, and I guess this branch is sort of self-contained, right? So the idea of this is that this is just testing to see whether the contents of the local variable x are currently less than 10. And if they are, then we start again. And the end effect here is that we end up adding 3 onto the current value of x, because the top two values of the stack are x and 3. So this is just going to be adding 3 each time around the loop. So that, these initialize x to be 3, essentially. These two values get added together. And then each time around the loop, before we branch here, we make sure that we've got 2 more values on the top of the stack ready for the block to consume. So it's actually more complicated, because as this says, depending on what kind of branch we're taking, it has a different effect on the stack. Taking a branch unwinds the operand stack up to the height where the targeted structured control instruction was entered. However, branches may additionally consume operands themselves, which they push back onto the operand stack after unwinding. So, and then there's some stuff here that says forward branches require operands according to the output of the targeted blocks type, i.e. represent the values produced by the terminated block. Backward branches require operands according to the input of the targeted blocks type. So what this is saying is, when we take a branch, whether it's a forward branch out of a block or an if, like if the block was supposed to produce 2 results, then effectively what it's saying is that branch instruction consumes those 2 results off the stack, then the stack gets rewound, then it pushes those values back onto the stack, and that's the result of the block. And if we're jumping backwards to the beginning of the loop, then instead of worrying about the result of the block, it's worrying about the input of the block. And first, if the block takes 2 arguments, it has to pop those 2 arguments off the stack, then the stack gets rewound, and then those 2 arguments get pushed back onto the stack. So I'm going to need to get that right, and at the moment I'm definitely not. There's all kinds of faff going on here. I think the fact that I haven't properly understood this is a little bit annoying. But also you can see this business I'm doing here, stack.push saved operands. I mean, this whole thing is ridiculous. Okay. So I've reverted all that stuff. So firstly, saved operands is a silly name. That should be result values. So surely that all still works fine. Let's make another tab. So yeah, let's just assume this is working. So this is just rename saved operands local variable to result values. This is actually what they are, which will become clearer when we only push them onto the stack in the case of a forward jump. Can I link to this? I wish these individual paragraphs were linkable, but it feels like this is probably the best I can do. I.e. a branch out of a block or if, and not in the case of a backward jump, i.e. a branch out of a loop. Yes, okay, pending test failed successfully. Okay, cool. So that's helped to silence that particular voice in my head. But yeah, as I said in that commit message, we actually need to know, like, it does actually matter whether we're doing a forward or a backward branch. And that's currently what this redo on branch is telling us. And it's sort of a miracle that anything works at the moment, because according to what the spec says, it should be one or the other. Like either this branch, if it's a forward branch, it should be doing the work to make sure that the result values end up on the stack, which is what we are always unconditionally doing. Or if it's a backwards jump, then instead of this, I mean, it also needs to rewind the stack, which is what this is doing. But instead of these bits, it should pop off the argument values, then rewind the stack, and then push them back on. So let me just think about what that means. I'm trying to think about whether this is still what I want, because I'd sort of undone this on the assumption that I wanted to push them inside this block, but that's actually not right. It's the branch. It's the branch that has, this is rewind the stack. Unwind is the correct. That's where the stack gets unwound, is where we pop off everything that is all of the surplus stuff. So actually, I think this original setup is probably correct, because for the first iteration of this block, we do just want these values to be on the top of the stack, and it's only for the purposes of unwinding that we want a smaller stack height. And of course, I could pop these off the stack and then measure the height of the stack and then push them back onto the stack, but that's... If I'm not doing one of those things inside this block, then that's just completely pointless work, and I might as well just subtract. So I think this subtraction is correct, because it allows me to unwind the stack to the correct height. So that seems okay. The thing that's not okay is that the sort of before and after need to be different, depending on whether Well, why don't I sketch that out? It's really annoying that I'm going to have to do this twice because of this duplication, but let's just stomach it for now. So let's just say if redo on branch to do else pop, and then we always unwind the stack, and then we say if redo on branch to do else this. So actually I can see that I'm just going to be able to, I won't need this second conditional because this will just assign some local variable that's what we want to restore to the stack. But for now, I'll keep them segregated. So, I mean, I'm using redo on branch. I chose this name. I can't remember what name Chris chose for it. Probably a better one than I've chosen. I chose this name because it was a sort of a does exactly what it says on the tin, which is when you get a branch, do you want to redo if redo on branch inside the, the branch handler. Chris probably had a more sensible idea because really it needs to be called like backwards jump. What did you say, Chris? Yeah, basically branch to sequence start. So that is more or less backwards jump. So yeah, with the benefit of hindsight, I think that would be a more sensible name for this. But what I'm trying to do here is this. Why is this code even duplicated? What's the difference? Oh, it's the else branch that's different. Oh, and the condition. Okay, right. But all of this, I think I can just copy. Okay, so what I'm saying here is that... Oh, and I guess the redo can actually go inside here, right? No, I'm not going to do that because, like I said, I think this is going to collapse down to a single thing. So if we're going to do a backwards jump, I think we should leave the stack, or at least what we should have been doing, because we hadn't thought about it at all, was leaving the stack alone. This nonsense that I was doing to try and put the results, like pushing the result onto the stack after unwinding the stack, is just total nonsense because we're not returning a result. We're jumping back to the beginning of the loop. So that was just totally bogus. So what I'm curious about is, do block and if still work under this regime? And the answer is yes. So at the very least, that shows that, well, it doesn't show anything, does it? Let's just see what is happening here. What I'm expecting here is to see maybe not the same failure, but a similar one, because we're still not doing the right thing. Yeah, I mean, it is slightly different now. Now it's saying for length mismatch. I think previously there was a different value on the stack. Yeah, there was a 3 on the stack. So I mean, it's not very different, but it is at least a bit different. And I assume that's because I'm no longer popping and pushing all this gubbins before I, around the stack unwinding. And I mean, it's really amazing that I didn't even think about this before because what I implemented just didn't make any sense. But, in my defense, it's because I didn't understand it. And now I feel like I do understand it a bit better. I mean, I remember seeing this before and not understanding what the heck it was talking about. I'm sure that in a previous video you can find me reading the sentence, however, branches may additionally consume operands themselves, with a just abject confusion on my face because I didn't I didn't get what that meant. Now I get what it means, which is that it's the act of branching that has to deal with the stack unwinding, and it has to deal with coping with either the result values or the parameter values. And I think the reason why I'd missed that is because that's not part of the semantics of these instructions. Because all the work is being done by the branch instruction. It's not, I was thinking about this as being part of the implementation of block and the implementation of loop, but it's really part of the implementation of branch, isn't it? So what does this say? So there's some detail hidden here, which is that it says, this is what I was saying, is that it's essentially the same operation either way. The only difference is how many values are you popping and pushing. And I think it's all hidden in this step 3, which says let n be the arity of L. And that's the detail I missed here, is that I said, the only difference between block and loop here is that this one says whose continuation is the end of the block, and this one says whose continuation is the start of the loop. But that's not true. Look, this says let L be the label whose arity is n, and that is the result type. So n is the sort of result arity of the block, if you like. How many results does the function type specify? But here it says let L be the label whose arity is m, and m is the input, the sort of the input arity of this function. It's like how many arguments does the block take? And that, I think, accounts for the whole difference, that you just need, or you need to pay attention to the input or the output type of the block, if you like, depending on whether you're jumping back to the beginning or jumping to the end. Because obviously if you're jumping to the beginning, it's going to need some input. And obviously if you're jumping to the end, then the next instruction is going to be expecting some output. And so the interaction between the choice of letter here, M or N, the where the continuation is, whether it's the end of the block or the start of the loop, and the fact that branch here is just using generically what the arity of the label is to achieve the effect, all of those things together, I now understand gives the correct behavior, but I hadn't understood any of that before. So now I do understand it. The next step is to implement it. Chris says, my vote is for having separate forward and backward jump block methods. Yeah, I think you're probably right, Chris. Now that I this is always a code smell, isn't it? Like in fact, I think there is a code smell called like Boolean argument or something. It really indicates. I assume that what you're saying is that we should have two different branch handlers. Is that what you mean? That there should be a sort of with forward branch handler and with backward branch handler or something that implements this stuff differently. And that is now how I feel. Especially when I've removed this duplication here. Yeah, okay, good. I have correctly understood you. Once I've got rid of this string thing here, I think there's very little value in having these be separate. Although, well, let's see how this shakes out. But I think what the formal specification is indicating here is that actually, kind of as I was intimating here, I think really this branch of the conditional is going to be pretty much the same as this one, and this one is going to be pretty much the same as this one, differing only in this or this. Like, the only difference here is how many values do we push and pop. So I think that this branch here is going to be stack.pop type.parameters.length. Let's just do this. Let's do this longhand for the sake of argument. And if this makes the test pass, then that will confirm that I've understood it correctly. I said that last time and it didn't work, so I've done it again, haven't I? I mean, maybe argument values isn't right either. Maybe it should just be arguments. All right, I'll just leave it as parameter values and stop fussing with something that doesn't matter. I suspect this is going to go away anyway. Because, yeah, you can see that what's going on here is that it's the same. You know, that's why this doesn't have... That's why the operational semantics of branch doesn't say, oh, if it's a forward branch or if it's a backward branch, do something different. It always does the same thing. It's just the arity of the label is different. And that's what this is indicating, is what is the arity of the... Well, the label is where the branch is going to. Like, what's the continuation? And the arity of the continuation that is the end of the block is how many values is the code after the block expecting to be on the stack, and that's the result type of the block. If the continuation is the beginning of the block, then the arity of it is how many values are the start of the block expecting to have on the stack, which is the input type of the block. So this all makes sense. And really, it's so simple that I should have realized it the first time I encountered this, but I am quite slow. Okay, so again, if and block are working correctly, let's see what happens with loop. Hey, yes! I understood something! Woo! All right, that's cool. I have understood something. How am I going to translate that understanding into a commit? I think the only thing that varies is the arity. So I think up here, I'm going to do something like arity. I'd like to have something more specific than that, but let's just say if it's redo on branch, then it's type.parameters.length. Otherwise, it's type.results.length. I mean, am I jumping the gun here? Should I just commit this? I mean, this, this makes the test pass. So maybe I should do that. Maybe I should just lock it in, even though this is ridiculously verbose. This does at least express my understanding at the moment, and then I guess I can extract the arity. Right, error, pending test passed. Quite right. Oops. Okay. I don't need this anymore. So yeah, I mean it's pretty grim, but let's just do it. How do I want to explain this? Let's say restore. What language does this use? Yeah, I mean, it just calls them operands. Restore the correct... I'm struggling to think about how I'm going to write this in a single line. because it's like restore the correct number of values after unwinding the stack after a backwards jump. Restore the correct number of values when unwinding the stack after a backwards jump. Yeah, I'm just gonna say that. It's a bit long for a commit message, but whatever. Let's say, I think maybe I'm just going to reference this again. The specification says that backward jumps, i.e. branches inside a loop, what does it actually say? Should pop off the number of values corresponding to the input type of the loop body and restore them after unwinding the stack. Let's just put this here. The specification says that backward jumps should pop off the number of values corresponding to the input type of the loop body and restore them after unwinding the stack. Previously, we were totally ignoring this and always using the number of values corresponding to the block's output type, which is why the loop.wast tests were failing. They're all passing now. Okay, so that's great. Now I'll clean this up. So yeah, what I wanted to do before was have a sort of make a decision about the arity. So if it's redo on branch, then it's type.parameters.length. Otherwise, it's type.results.length. This just becomes arity. That just becomes arity. That just becomes arity. That becomes arity. I'm just making the smallest possible change here. Maybe it should be like branch arity. Yeah, I think I like that a little bit more. The spec calls it like the label arity, but I'm not using a label to do this. I'm, using Ruby native. The expectation of the operational semantics is that you're literally creating labels and pushing them onto the unified stack, and I'm not doing any of that. I'm using catch and throw inside Ruby. So, but I think branch arity is a legit way of characterizing that. So I think that's fair enough. Okay, so let's commit that because that's a meaningful change. Say something like pre-compute branch arity based on forward, backward, branch. It's a forward or backward branch. I'm not being charged by the letter. And now I can just get rid of this conditional, right? So if this is, if I just call this like branch values, and then this can all just go here. Is that okay? So we're sort of popping off and then pushing back on. Yeah, I think that's fine. So we sort of do the unwinding in the middle, and then there's this, we're testing this again. So yeah, I mean, I guess, Chris, where my brain was going before is that I think the fact that this is sort of generic, like once you know what the arity is, this logic is the same, makes me slightly less inclined to split this into two different methods. But I'm not sure. I'm just going to not think about it for now. So I'll say unify branch handling code for forward and backward branches. I've sort of said branch and jump interchangeably in these commit messages, which is what I was just checking, but whatever. And I've also said forward and forwards and backwards, but it really doesn't matter. So let's just say here, the forward and backward cases differ only in the arity of the branch, but now we've extracted that, we can just use the same code in both cases. Okay, so that's good. I feel like I have understood it more. Just thinking about this arithmetic. Hello, hi. Hello to Ruby Turkey. Thanks for coming. Welcome. Is it Yashar? I'm not sure how to pronounce your name, I'm sorry, but welcome in any case. So, yeah, what I'm thinking about is, what's the point of pre-computing this subtraction when I could subtract it down here? But maybe this is just easier to understand. Like that's what I'm hesitating over here, is like, what's the easiest way, what's the clearest way to deal with this? Because at this point, these parameters haven't actually, the arguments of the block haven't actually been consumed yet, but we know that the body of the block is going to consume them. So they're as good as dead to us. So I'm just thinking about whether it makes more sense to subtract it here or to sort of subtract it afterwards. Oh, it doesn't matter, does it? I think it might be a little bit zero sum. Oh, I've got a... Where's that happened? Oh, it was just me messing around. Yeah, I can't see a cool way of making that problem go away. So we might as well do it up here, because then, you know, more stuff is happening down here, and I think this makes it easier to understand. And then there's just a question of like, well, why are we subtracting the number of parameters at the beginning there? But the answer is because we have to. Okay. All right. I'm going to drink some water and think about what to do next. So, I've definitely done some of this. Account for block parameters when evaluating loops. I am now doing that. I've got loop.wast parsing. Yeah, I moved this one to the top, and this is definitely relevant. Use identifier context to replace symbolic labels with integers. So yeah, as I said, the fact that we don't have that is why I have to have two different cases here. Okay, I can get rid of that. We don't have any more things here that say they need block types with parameters, so that's rather unfortunate. Everything else here is sort of miscellaneous stuff. Although I see that now these are next to each other, we need load n and store n, so that's perhaps low-hanging fruit. So I'm going to add that to my to-do list while I remember it. So that maybe feels like an obvious thing to look at next, after I've, you know, done whatever else I want to do with this. Hadn't really gone back and reviewed. In fact, why don't I get rid of all the things that I've done? It always feels like a bit of a shame to delete all this evidence of my hard work, but so it goes. Yeah, get rid of parameter and result AST nodes. I think they are just types, so I think I probably can get rid of those. But there's no pressing need to do that. I know that I've got tests that need this spec test module. I just haven't thought about that yet. Yeah, there's this single pass over the S expression business, which I think is going to be a bit of a mess. More carefully about how to deal with updated type defs. Why don't I have a look at... really, I'm just hunting through here looking for something that I can do to take a breather before I move on to something more painful. Maybe I can... Because this says refine data with. I think what this should say is use Ruby 3.2's data with. I don't need to refine it anymore because it exists. There are places where I'm making... Oh, look, here's one. I guess what I should be searching for is that. Oh dear. Oh, there's only one place where I do that. That's a shame. Sorry, I've allowed myself to be derailed by this, but maybe I should just do that. So this is context.with type defs. So yeah, I'm just being opportunistic that now there's an easier way of achieving that. I don't think. Oh, there were actually two of them. Okay. Okay, well that's worth doing, and then I can check this off, and then I've, I don't know that I deserved a treat at that point, but I feel like I've given myself a little treat in that I've got to use a new a feature of Ruby 3.2 that wasn't in 3.2 pre-3 or whatever it was that I was using before. Okay. Use data with to update context in parse function, parse block type. This isn't a big win, but data with was introduced right before Ruby 3.2 was released, so I was excited to get to use it. Now I've had my fun and can get back to work. Okay, well that's a little nice. There goes that stretch goal. Oh well. That wasn't as exciting as I thought it was going to be honest. I wonder if I have any other. Let's just see if I have any. What am I looking for? New double splat. How much of this am I going to have to escape? Ooh, look. There's lots of that in float.rb. Ooh. So could this be self with sign? Oh, hold on. I don't even need... Okay, well, let's take this a step at a time. But this whole method can go away, can't it? Okay. Oh, no, this whole method can't go away because of reasons. Because this doesn't have a sign. The sign is encoded in the rational, so I need this for sort of polymorphism purposes. But if the tests still work, then that's rather nice, I think. In fact, I don't need to say self, do I? Because in Ruby, you don't have to specify the receiver if it's self. Unless it's a setter, of course. Or a class method. Well, yeah, in that context, a class method. Okay. Okay, one more time. So that is actually, I think, quite a lot nicer. Use data.with in with sign implementations on floats. We still need with sign so that it can be used polymorphically, i.e., is it? It's finite, presumably. Yeah, that must be. Wasmina float finite doesn't have a sign. What is it called? The members? That's what struct calls them. But the implementation is now much nicer because we can use data with to copy all of the other members instead of having to call to hash. Okay, well that actually was quite a nice treat. I like that. Thanks Ruby, thanks for fuck. All right, back to the actual WebAssembly minds. Use identifier context to replace symbolic labels with integers. Yeah, I really should do that, shouldn't I? How are we getting on in the interpreter with respect to things that could be strings and also could be integers? So labels could be strings. Oh, is this the last one? It might be. I mean, I remember I had several cases that looked like this that were distinguishing between string and integer. So this might be the last holdout, actually. So I think I probably should do this. Okay. How's this going to work? So we need to, well, let me see if I can find in the spec where they talk about this so that I can use that to clarify what it is I'm talking about. So when we take a branch, so it's probably in control instructions. Why did I do that? Control instructions. We can branch to a label. Now, here we go. Structure control instructions can be annotated with a symbolic label identifier. They are the only symbolic identifiers that can be bound locally in an instruction sequence. The following grammar handles the corresponding update to the identifier context by composing the context with an additional label entry. So we should have in the identifier context, AST parser, we should have, well, we don't actually, but we could have labels. And at the moment, we've just got types, functions, globals, locals, and type defs. Okay. Yeah, I'm just remembering how all this stuff gets populated, but this is, it's build initial context that fills in the types and the type defs. Yeah, okay. So at the moment we don't have any, we don't put labels into the, we don't put labels into the identifier context, but if we did, then when we encountered a label, we could look it up in the identifier context. Right. Okay, so this is saying when we encounter a label in a situation like this, so when we are labeling something, if we are labeling a block instruction, a block or a loop or an if, then what that does is it's sort of the synthesized attribute or whatever it's called, the result of parsing this label is going to be a new identifier context. And this is saying label can syntactically be two things. So you can see here the label is mandatory. This isn't an optional label. You always have to provide a label after a block or a loop or an if. But then what it actually says is that a label can either be present or it can be empty. So this epsilon is like the empty string. So if the label is present, then it has to be syntactically an identifier. So it has to be dollar something. And if it's present, then you have to prepend it. So this says the new label entry is inserted at the beginning of the label list in the identifier context. So this composition of identifier context is specifically ordered, or this is just composition of records actually. But whenever you compose records, it's like an ordered. So this thing is going to be stuck on the beginning of, if the identifier context already has any labels in it, then this is going to be pre-pended to the list of labels. So that's what I would expect, and that's what this is saying. This effectively shifts all existing labels up by one, mirroring the fact that control instructions are indexed relatively, not absolutely. So as we enter nested lexical scopes, if they've got labels, then the most recent one becomes index 0, and all the ones above it get bumped up to index 1, and then index 2, and then so on. So finding a label updates the identifier context to bump all existing labels up by 1, so their indexes are incremented, and then in the 0th slot we slot in the current label. And in fact we do that even if the label's not there. So even if it's empty, we still need to, effectively the purpose of this is to still increment all of the other labels even if we're not actually inserting an entry for this one, because now the index has to be how many scopes are you trying to branch out of. So we need to, having entered a new scope, we still need to increment the indexes of all of the other labels even if we don't have a new label to insert in the 0th slot. So that's what the parser should do when it finds one of these instructions. And then the flip side of that is when we actually do a branch. So a branch can either, this label IDX is like, it can either target a symbolic label or it can provide an integer. And I think if we look at this, it will say label IDX is either already an unsigned 32-bit integer, in which case that's what we store in the AST is just that number, or if it's an ID, so if it's one of these dollar prefixed symbolic identifiers, then we have to look it up in the identifier context. So we say we get the number L if the Lth label in the identifier context is that identifier V. So that's just saying look it up in the identifier context. So I think that's all we need to do. It's like during parsing, we just have to, as we descend into those nested lexical scopes, we need to remember, we need to update the list of labels to include the current label, even if there is no label, in order to increment the indexes. And then whenever we actually want to dereference a label, rather than potentially storing a string into the AST, we always just look it up in the identifier context. And then the only fiddly thing is making sure that, well, I think perhaps we already get this for free. I was going to say making sure that we undo that change afterwards, but I think I've already got this like with context helper. So I think if I'm not already doing this, which I'm probably not, but I can just use this with context helper to say, well, when we start parsing the body of a structured instruction, we do it with this new context, the extended context that's got the potentially empty label pre-pended to the list of labels. And then when we leave that Ruby block, the whole point of this with context helper is that it restores the old, remembers the previous one, and then it restores it after after that block's finished evaluating. So I think this is probably all quite straightforward. But we need to... Oh, and the other detail that I remembered but I didn't mention is that we've got to check this side condition. So this is saying we can only prepend the symbolic identifier V to the list of labels if it's not already in it. And I mean, that's something that would have been checked by validation or whatever, but I think for the sake of... Well, this is pre-validation, isn't it? This is just parsing. So I think it should just straightforwardly be a syntax error if you try to say, here's a block with the label foo, and inside that, here's a block with the label foo. We don't even get to validation. We say there's a syntax error. You can't shadow one label with another label. They have to be unique they have to be unique in that particular path through the nesting of lexical scopes. So you can't have an ancestor label that has the same name. So, yeah, we just got to remember to check that so that we get a syntax error in the right place. Or at the very least, so that things don't go wrong in a weird way. So I'm going to sort of sketch this out, and then I'm going to think about what commits I want to make here. Because there are a few things I know that I need to have. Let's look at the definitions of identifier context. Types, funcs, tables. Have I heeded this? Yeah, I think I have. So labels comes before type defs. So let's do that. Labels. And then here we're going to say labels is empty. Yeah, it's kind of annoying that I'm having to keep adding all of these, but I think that's okay. I'm just trying to think if there's a nicer way of achieving this, but I don't know a nicer way. I know there's been a bit of controversy in the last few days about this. I know Aaron in particular doesn't like the fact that the new class method deals with handling positional arguments, and then so that the initializer can always just deal with the keyword arguments. I mean, I don't have a horse in that race particularly, but it makes me slightly more hesitant to dig in and try and figure out if there's a neat way of doing this. I think I'll just keep making these lines longer. So that's introduced labels. I'm just thinking about what does this do. Yeah, I mean, this operation is just that generic record composition I was talking about before. So for the purposes of composing to context, we don't need to do anything special for labels. In fact, this is already enforcing that sort of uniqueness constraint. Why is type defs excluded from that? I suppose it's because it's fine to have multiple... There's no rule that says you can't have multiple type definitions that have the same signature. I don't know why. Oh, I guess it's because... No, okay. It's because the well-formedness constraint says no index space contains duplicate identifiers, and type defs doesn't contain identifiers, it contains types. So we don't care. There is no well-formedness constraint on type defs, basically. Okay, so I think that's all that's necessary to get labels into the identifier context. So now, well, maybe I can make it break by trying to look up labels when I find them. So where would that be at the moment? Is it just in BR and BR if? Let's just have a look at the AST. BR if, define index, BR table, target indexes, BR define index. Yeah, I suppose these are all... Except these table indexes are different, aren't they? This looks in the tables, not labels. Oh, but it's call in direct that uses that. Sorry, I was looking at the wrong thing. Anything here that says syntactically label IDX is fair game. So I think... it's finding them, but because they're in the MathJax, I can't see where they are. But I think it says it can only find 4. 1, 2, 3, 4 of 4, and I can see 4 of them here. So in a fantastic collaboration between human and machine, I think it must be these 4 places that we've got these label indexes. So it is BR, BR if, and BR table. So what I was going to do was... Well, maybe I could just pick one of these. Maybe I could just pick BR to begin with and sort of deliberately break it. Oh, yeah. Okay. Okay, so what's going on here? So this is what... So yeah, actually, it's maybe not straightforward. So this is saying... Well, no, like I can make it straightforward. I can say in BR... Because actually, what's going on here... Parse index, right? And I've got a to-do about this, haven't I? Push context lookup into parse index. Need to pass in context and index space. This might not be possible or practical. Anyway, so this doesn't attempt to do any kind of lookup. This just deals with essentially reading the index. And this returns either a string or an integer, depending on what I actually managed to read. And then we have to do this. We have to deal with actually looking it up in the identifier context. So I guess here I could do context dot labels dot index of index or raise. So I think that's what I meant by breaking it, was setting it up so that we are trying to look up the label in the identifier context, but we haven't yet done any work to actually make it be there. So the reason I'm doing this is because I want a failing test so that I can then make that test pass. Because there's no point in me trying to implement something if I don't have any... If I don't have a failing test to tell me when I've actually implemented it. Okay, so what test was this? Well, perhaps unsurprisingly, labels.wast. Okay, good. All right, well, the fact that there's a labels.wast is quite reassuring, isn't it? Because will give me something to work with. Okay, so presumably it's immediately failing at this point. Doesn't say. Of course, I don't have any kind of information because I'm not annotating the S expression with line numbers like Chris Zeta probably wanted me to do. Still haven't done that. Sorry, Chris. But yeah, as soon as it finds this, it's going to fail to look that up. So let's make it so that it can. So what is it? Where do we look for block? Parse instruction, parse structured instruction. Oh, this is probably a folded instruction though, isn't it? So it's probably in here. Read labeled, opcode, comma, label. So yeah, it's going to read block, and then it's going to read the label, and then we're trying to parse the block type, which is this piece. And then we descend into the bowels of the body of the block. So all of these. So really, this should be like with context, context with label, basically. Because actually we need an extended identifier context to make sense of the body, because the instructions here are going to probably, or at least potentially, contain references to that label. Wow, hi. Hello, our teacher gave us homework to interpret WebAssembly and I used your streams as inspiration. Great work and keep it up. Thank you very much. That's very kind of you to say. Wow. Well, if this if this project has helped one person understand WebAssembly, that's not me, because it's debatable whether I'm understanding WebAssembly, but if that's helping you, I'm very grateful. So thank you very much for telling me. That's given me enough motivation to continue for another 100 hours. Thank you very much. So I'm just thinking about, what am I thinking about? I was sort of thinking about this label that's being baked into the block AST node, because we don't actually need that, do we? At least we won't at the end. So maybe I'll make another to do here that's like remove label from block loop and if AST nodes, just in case I forget. So I don't think I need to worry about that. I think that's just going to evaporate when I'm done with this change. So I just need to... What do I normally do when I call with context? Like, how do I extend the context? I mean, what the hell is this? With context, context? Do I really mean that? Okay, with context, initial context. With context, context.new. Right, this is the context plus locals context. So I think I probably want something like that. You know, context. Oh, in fact, it needs to be context.new labels. It has to be this way around, right? Like that's what the spec was saying, is that actually this has to be prepended. Oh, this has got a blue box around it. I was not expecting that. Oh, I can't find it now, but you remember. Oh, it's probably here. Yes, it has to be a prefix there. And this parse block type could well... No, that's not what I'm interested in. I'm interested in read labeled. Yes, the label can... Yes, the label will be nil if there isn't one. I was focusing on this line and being a bit confused, but actually this is the relevant line, is that we don't even try to read a label unless we can see that there is one syntactically. So label will be nil here if there is no label, and I think that's just exactly what we want. I think we just want to put label. We just want to make a one element list that's either the actual label we've been given or just the empty string, nil in this case, and prepend it to the context. Now, is that gonna... okay. Still not happy. Oh, in plus, unhandled exception. Okay. Raise and left intersection right, compact, empty. Why would it not be? I'm not sure I understand why that's happened. I mean, I'm not checking that side condition yet, but I wasn't expecting to need to. Oh. Well, something has gone wrong, hasn't it? L1, L1. In fact, this makes me suspect that, well, we don't get any progress, do we? Because we have to parse the whole file. I was like, I think that this might have got further than previously. But that's somewhat irrelevant because because we don't even try to run any assertions until we parse the whole thing. So let's look at what's going on here. $L1. So it says shadowing. Hold on. How is this allowed? How is this allowed? Yeah, I mean, I just got done saying that you're not allowed to do this. But maybe you are. Hold on. My brain is just short-circuiting because I don't understand how this is supposed to work. Like, how can this be legal given that I really don't understand this. Given that, well, there are two problems here. Firstly, the well-formedness of identifier contexts in general depends upon there not being any duplicates. So you're not allowed to have this labels index space have duplicates in it. I mean, it wouldn't bother me, but that's what this says. I mean, I don't know when well-formedness is required, but it seems like you should be requiring well-formedness in some important places. And secondly, I think that composition operation on records is, well, actually, I'm not so sure about that. I was going to say it's not defined if they're not unique, if there are duplicates, but maybe I just imagined that. Composition of a sequence of records. Yeah, actually, so it says that this is just appending each sequence pointwise. So this actually doesn't say anything about uniqueness. But my assumption is that well-formedness is important. But that's irrelevant because this says that you can only do this if I'm very I don't know what to make of this. Shadowing and redefinition should not only parse but successfully execute. So what am I not understanding about this? Hello, Chris, Lois, welcome. Unfortunately, you join at a point where I'm very confused. I do not know how to reconcile this. I mean, I could just ignore this. That would be fine. Yeah, yet again I'm confused. And specifically what I'm confused about is that I'm trying to parse a WebAssembly function that has got a block with a label that contains blocks that reuse that label. So these instances of the label L1 are shadowing this definition of the label L1, which is fine, and I understand what it means, but it looks like the specification says that you can't do it. And probably what that means is that I've misunderstood the specification. But this makes it look very much as though you're not allowed to do this. Okay, well, I don't think I'm going to be able to get an answer to this. Label. I mean, this test is clearly showing that you should that this has to be allowed. So clearly, I'm going to have to make this allowed. It just makes me very uncomfortable that the spec says that it's not allowed. I mean, maybe the problem is that I'm over-egging the... maybe the explanation for this... Well, I was going to say the explanation is that it doesn't have to be well-formed all the time, but... But it's extremely bothersome that this definition of the sort of synthesized attribute here, when you parse a label, this rule is only... It's got a side condition that says you can only use it if it doesn't appear in the list of labels. So I don't understand. How's that allowed? It just doesn't make sense. I think I'm going to have to just, for now, ignore that and pretend that it didn't happen. I mean, it doesn't explicitly say anything about... Oh, I mean, the search is useless because of MathJax. But it doesn't say anything here about label shadowing. Okay, well, I give up. I don't understand. I mean, it's not impossible that this spec has fallen out of sync with what's allowed, but I'm just conscious that every other time I've thought that there was a problem with the spec, it was actually a problem between chair and keyboard. So I don't want to tempt fate by making some kind of, hubristic proclamation that I found a problem in the specification. I think it's far more likely that I've just misunderstood. Anyway, I mean, I guess I'm just going to have to fudge it to make it work, which looks like... type defs labels include key, which is to say exempt labels from the uniqueness checking because they clearly shouldn't be subjected to it, because unless... Here's the thing I might be... Well, surely this can't be the case. No. I was going to say unless the intention is that we ignore these, but that can't possibly be right. The intention here cannot possibly be to say it's syntactically valid to repeat this label here, but it does nothing. I mean, there's no case here that says, oh, otherwise we just return the unmodified identifier context. Like, if this side condition isn't met, then this is like a parsing error. So yeah, that I had a brief ridiculous thought that maybe this label here is supposed to refer to this instance of the label because shadowing is not supported. But that would be absolutely absurd if that's how WebAssembly works, and I flat out refuse to believe it. Okay, right. So that has fixed it. So, I mean, that's very upsetting. Well, that's not true. It's mildly irksome that I have clearly failed to correctly understand what the specification is asking me to do. Okay, this is what I was expecting, because I need to also do that same work in when we parse unfolded structured instructions, which is just parse structured instruction. So yes, unfortunately, I need to repeat the same business here, which I do not feel good about. Maybe this can go inside this, actually. Just thinking about what the extent of that is, but actually, as long as we only need this extended context for the purposes of calling parse instructions and parse consequent and parse alternative. I mean, I could push it deeper, but I think this is a convenient place to put it because we're going to need it for all of the arms of that case. Okay, well, let's see if that fixes the problem. I mean, it has put me out a bit. I don't feel good about that. Up until now, I've been able to take a relatively principled approach to implementing this, where I sort of understand what's in the spec when necessary, and then I make it work. And I feel like I haven't done that. In this case, I've just sort of bodged it. No, I'm just going to have to... It's a very attractive nuisance, because I would love to dig into that, but I'm going to try and stay focused. I mean, why don't I'll make a note here. Understand why the tests are allowed to shadow labels existing labels. So let's say e.g. the redefinition function in labels.wast when the spec, and what am I talking about here? Says that they have to be unique in the identifier context. So tempting to try and... I'm going to resist the temptation, but it's so tempting to try and understand that right now. But I'm going to charge on with what I was doing. Okay, so what have I actually changed? So there's adding labels to the identifier context, allowing duplicates in labels, which is weird. Ignore all space because I don't want to, I just want to see that. So yeah, stuck a new context around yes. So this is when we introduce a label. So that's inside a structured instruction. And then for BR only, I'm looking things up in that context. So I think I need to also do it for BR if. And then I was under the impression that I also needed to do it for BR table. Is that right? Yes. So let's see if I can get that working as well. And then the proof of this particular pudding will be in the removing of the string handling code in the interpreter, because the idea of this code is that it is replacing what would have been a string with an integer. In fact, now can I get rid of this else clause? Because I think this is everything. Local get, local set, local t, global get, global set, br, brf, call. In fact, I'll put them in the same place. So I think, yeah. I mean, obviously, what's going on here is that we need to pick a different index space depending on what the instruction was. So this is a sort of limited value having them all in a single case there, but it's fine as it is. And yeah, look, we've got a little lookup table of which constructor to use to build the appropriate AST node. So that all seems okay. So BR table. Right, this just constructs BR table with where do these come from? Target indexes and default index. Oh, I'm sorry, they get they get pulled out of indexes. So I think I'm going to, inside this block, I'm going to do the lookup. So I'm going to say like index equals parse index. You know, what do I do here? If index is a string. Index equals context labels index or arrays. So that's the same code I did up here. I'm just doing it for all of the indexes, and I could map over it after. Yeah, maybe that's slightly nicer actually. Sorry, I should have just done that in the first place. Let's make this a case. Case index. Well, in integer index, in string this. And those are the only two types of thing that we allow. Is that slightly nicer? That's not great, is it? Well, firstly, let's see if that's broken anything. Doesn't seem to have broken anything so far. Okay, so that seems fine. And then, of course, the thing I actually want to check is, can I remove this? Looking hopeful so far, although I have to... Whenever I run these tests, the problem is I'm always like, oh, looking good so far. But then I forget that the first, 10 of these tests are just checking that integers and floating point numbers work properly. We're still not onto anything involving control flow. Okay, now we're on to stuff involving control flow. But I'm always like, in a normal, in a more conventional test suite, getting some test passing at the beginning is as good an indicator as any. But in this one, it's sort of specifically all of the early ones are the really simple ones, or at least they weren't that simple because I had to implement floats. But they don't involve any complicated programming language semantics. Okay, so that worked. Okay, well, I think that's... I feel like I'm getting too... I'm drifting too far without having made a commit. So let's get started with that. So I think this first one is going to be just adding them. So this is just like add labels to... add label index space to identifier context. We want to use this to keep track of labels as we parse the bodies of blocks, so we can replace symbolic labels, symbolic identifiers, with numeric indexes at parse time. No, that's fine. Okay. I don't think I can add the code that creates the extended contexts, which I think would be the next step, until I've exempted labels from this uniqueness check. So I've sort of been dreading adding this because I feel like it needs an explanation. But let's say exclude label index space from identifier context well-formedness check. And I've got this link here, haven't I? I'm not happy about this because the spec says that labels, well, let's say strongly suggests that labels, well, that we're not allowed to put duplicate labels into the label index space of the identifier context. Well, let's just say into the identifier context. Implies. But some of the test cases, e.g., what was it? Definitely shadow outer labels in definitely have nested blocks which shadow the labels of their enclosing blocks. So it looks like we have to support it. I expect I've misunderstood something about the spec, but despite a few minutes of exploring, I can't work out what that is. It's not impossible that the spec is wrong about this. It's just much more likely that I've misunderstood it. Okay, so then the next thing is, I mean, this looks horrendous, but I assume this is all just nested. Yeah. Okay. So, yeah, so this looks like, this is where we extend the, so this is like add new labels to the identifier context as we discover them. And again, I'm going to say, per the specification, it's important that the new labels are prepended to the existing labels in the identifier context, so that the indexes of all existing labels are incremented. It's also important that we do this even when the label is not present, i.e. it's nil, so that we, so that those indexes are still incremented. I haven't done anything about the side condition stating that the label can't already appear in the identifier context, because that doesn't seem to be true in practice per the previous commit. Again, it's likely I've just missed something here, but it definitely doesn't appear to be, definitely doesn't look like it should be a syntax error, because it's something the official tests do. Shrug. Okay, well, I think that effectively communicates my confusion. So, I think these two essentially go together. So this is like look up labels in identifier context during parsing. This means that we're no longer storing strings in the AST nodes for the BRIF, and BR table instructions, the target of a branch is now always represented with a number, never a symbolic identifier. Is always represented in the AST with a number, never a symbolic identifier. In the next commit, we'll be able to remove the code, remove the interpreter code, which handles symbolic identifiers as branch targets. Okay, so let's do that. Well, let's just do that. Remove interpreter code, which handles symbolic branch targets. Keep spelling interpreter wrong. It's a typing problem rather than a spelling problem, I think. My brain knows how to spell it, but my fingers don't know how to type it. The abstract syntax parser now replaces these with numeric indexes. Okay, now an obvious thing to do here is that this is a bit silly. So this should just say, I think this should just be a conditional now. I think this should just say if result, well, I think what it should say is unless result equals did not throw, then we do this. I think maybe that's nicer. So this will just be like simplify conditional. Simplify result conditional in with branch handler. And I'll say the branch, yeah, if a branch has happened, its target will now always be an integer, so there's no point doing a type check. Yes. And I hesitate slightly because we're then testing to see if the result is 0, so we could have left this as a case, and the case just could say like in 0, but kind of, for some reason I didn't like the idea of that, so I'm just leaving it like this. Right. So as I said, remove label from block, loop, and if AST nodes. So we remove those labels. It doesn't appear that we have labels in the AST anymore, which is lovely. Okay, so we do need it there because it's a syntax error if else is labeled with anything other than the label that we got from the when we read the if, and similarly when we read the end, that's only allowed to be labeled with the matching label, but certainly when we construct the AST nodes we don't need the label anymore. So yeah, that's the only reason we pass an optional label into read labeled, is to have this sort of assertion so that we get pattern match failure if, thus a syntax error, if that label doesn't match. But that's actually the only reason we need it now, because we don't put it into well, obviously we need it here. That's all we use it for, I guess, is what I'm saying, is that it goes into the identifier context so that when we parse these instructions, we can look it up. Okay, is that still fine? Or is there something in the interpreter that's trying to use those labels? Maybe I can just quickly check that. Oh yeah, that is going to fail. Yes, okay. So at the very least I have to remove this, but then I really wonder whether there's any point in having... Well, I can't have a label argument to with branch handler because I don't have a label anymore. So I don't know what the label is. Okay, hold on. Let me just stash this a second, because I've jumped the gun slightly there. I think what I should have started with is removing all of the uses of the label. So here, what does it do with its label now? Nothing. So when I removed that case, that label argument became dead there. Well, so that's the right change to make, I think, is now that we're no longer using the label inside with branch handler, because it was being used in this equality check, right? So previously, when there might have been a symbolic label in the branch instruction, we had to be able to compare it against the label in the enclosing AST node. But now that there no longer is one, so I'll let that run through, but I think probably this is like remove unused label argument from with branch handler. Yeah, so this was used in an equality check when the branch instruction could contain a symbolic identifier, but now it can, but we have no use for it now that the branch instruction only contains a numeric index. Okay, and now I can go back to what I was doing. That allows me to remove the label from all of those. So does that work okay? In fact, it occurs to me that the code that was matching the label out of the AST nodes is no longer necessary. But maybe that's the next commit. Yeah. So here I'm going to say stop retrieving unused label from structured instruction AST nodes. This was only used as an argument to with branch handler which no longer accepts it. I think that I'm just running the test again to make sure I haven't overlooked something there, because I don't want to make a commit that doesn't make sense. But I think that change stands alone. It's fine to, I find myself thinking a lot about the sort of co and contravariance of like when it's okay to miss stuff out, but I think this is fairly obviously a place where it's okay to remove something that is there. If you've got a pattern that's matching against a data object, it's fine to only project out the members that you care about. Whereas when you're constructing one, that's not okay. It will raise an exception if you don't. If you miss something out. So I think this is the final step, that is remove unused labels from structured instruction AST nodes. These are now used entirely during, well, symbolic identifiers are now resolved into integers during parsing, so there's no longer any need to store the original label on the AST node. Okay, so I believe I've done this. Great. And despite the temptation to think about this, I am going to resist the temptation, because I think I could easily just waste a lot of time digging around in the spec trying to understand this. And, maybe someone will send me a message on the Mastodons telling me what's going on here. So while I'm cleaning up, I wonder if I can do this get rid of parameter and result AST nodes if they're just types. Let's have a look. Firstly, who mentions these? They are not mentioned at all in the interpreter, so that clearly isn't using them. I suspect that it might just be calling type on them. So like parameters, call length. Length. Looks like the interpreter only cares about the length. Oh yeah, why would it care? Good night, Chris. Thank you for dropping by. It was very nice to see your friendly face in the live chat. I'll talk to you soon. So yeah, this is nonsense. The interpreter doesn't care about the type of things. It just cares about arity. So that, and then we're going to have the same thing here. So actually, we really don't need to store these at all, at least as far as the interpreter is concerned. But I think I made a decision that I was going to hold on to them rather than just store the arity, that I'm actually going to hold on to the types, because I know that I'm going to need them for validation. So it's a little bit, you ain't going to need it, except I sort of know I am going to need it. So, and it's also just a little bit less clunky to have a list of types and then to be able to ask for its length rather than have to make up things like result arity, output arity and input arity and things like that. Being able to just say type.parameters and type.results is actually a little bit nicer. So I think I'm happy to leave that as it is for the moment. But I think that's illustrated that the interpreter does not care at all about what objects are in this array. It never interacts with them. All it ever does is asks how long that array of objects is. So the interpreter could not care less about whether those are actually instances of parameter and result. So yeah, so here, parameter new type. So the question here is, does anyone care that this is an instance of a parameter object? Could it just be the type? And likewise, when we parse result, does anyone care that it's an instance of result? There's something here about parsing result. Remove the distinction between parameter and result and local in the AST, since these are just packaging up a result type for a particular purpose. Input to or output from a function. They don't need to be distinguished in the AST beyond where they appear. Yeah, I mean, I guess that I will be removing that distinction if I remove those node types. I'm not sure that local is the... Yeah, I mean, local is... doesn't have anything inside it. So that doesn't appear to do anything. But I just feel like that's a slightly different problem. So I think I'm gonna separate that out. Remove the local AST node if we're not actually using it for anything. So I'm going to separate those out because I think it does make sense to just get rid of parameter and result. So let's say that we just get rid of it there and we just get rid of it there. I mean, this appears to be just the identity. Yeah, I suppose the deal here is that parameters can have names associated with them, whereas results can't. This is in a type definition, at least in an inline one. Oh no, you can put them. Yeah, okay, no, you can put them in a normal type def. I think they just don't do anything. Yeah, this parse parameter I think is actually doing double duty, and maybe that's confusing, but there is more than one place syntactically that you can see param and result, and these are just used in all those places, and sometimes the name is meaningful and sometimes it isn't. But yeah, there's definitely a similar thing here where we're sort of reading the names of locals that may be anonymous. Anyway, don't get distracted. Does that still work? So like they are no longer referenced anywhere. And no one seems to be... Oh, no, someone's calling type. Yeah, okay. Okay. So was that the only place that we were doing it? That might have been the only place that we were calling a calling a method. And why was that? So we parse a block type. Oh, right. Yeah, this was for, right. This is for where when we have an inline, this is a special case of when you have a block type, it can have this special form where it only has 0 or 1 result type. I wonder whether this is a bit naughty returning an array like that, because it could just be nil or the result type. I'm not sure, but that's not the current problem I'm trying to solve. Let's say, should parse block type really be returning an array? It could be nil or the result type, like inline result type, or in the general case, the type index. Okay, but yeah, that's not my current problem. So this can be like stop creating instances of parameter and result AST nodes. And I'll say both of these just wrap a type and aren't doing anything useful. It's clear from context, i.e. where they're stored, whether those types are parameter or result types. So we don't need to decorate them to differentiate them. And then I guess I can just remove them if we're not going to use them. Parameter, result. Or we could instantiate a type object to represent the special case. That might be nicer actually, because I've written that just because I noticed that we've got this. This is essentially a function type that's got an array of parameters and an array of results. So actually, when there's an inline type, maybe I could just synthesize this function type, and then that, you know, if it's empty, then it will just have empty arrays of parameters and results. If it's got one parameter type, then it would have one entry in that array, and it would just be, that would mean that the type of this thing, when you parse block type, you either get a type object or you get an index. But that's not very important. Remove unused parameter and result AST nodes. All right. Get rid. Get rid. Okay. Okay, what next? Yeah, I'm going to park the understanding stuff. I'm going to park this. Maybe I should just look at this. You know, this would be something fresh. Just trying to get load.wast parsing. Yeah, maybe I'll just look at this. This would be a change of pace. Hopefully wouldn't involve very much touching the parser, apart from to tell it that there's well, actually, I mean, this is parsed fine. It's just just doesn't work right. So maybe I'll look at these. There's nothing very, like, this is, apart from this, implement the spec test module, everything else here has got a sort of refactoring-y flavor, or a sort of an investigative flavor. So I'm just going to move everything else down. Because, yeah, this has just become a pile up of, like, tech debt that I need to pay down, which is fine, and I enjoy doing that, but I think I would rather think about, like, what can I do to actually get more test passing, because that's what gives me the momentum to keep going. So I think I'm going to look at that next. Unfortunately, that'll involve remembering how all of this stuff works, because I haven't thought about the memory stuff in absolutely yonks. So where's this failing? It's getting down to store n address. I mean, why and how do I even parse these instructions? How does that work? Let's just refresh our memory with how the hell that works, because I certainly, yeah, look, load and store, I've got this, like, type bits offset, which is very suspicious. It seems like I might have got over enthusiastic about that. Yeah, look, load 8, store 8, store 16. So I definitely can parse those, but it looks like I'm not doing them correctly. Okay, well, I mean, that's interesting. I obviously at some point believed that I knew what I was doing here, but I think it's obvious to all of us that I don't. In particular, I seem to be completely ignoring whether or not it says it's signed. So that's a bit optimistic, isn't it? I assume type here is being populated with i32 or whatever. Where does type come from? Oh, yeah, okay. So we get float or integer, and we get bits, but what we don't get is whether it's signed or not, and clearly that's not okay. So, all right, I'll add this to my pending. And I mean, what's just out of interest? Should I be thinking about memory as well? Slightly different problem. Memory dot size, no matching pattern error. So was I just wrong about this? Like this memory wast, it says needs load n and store n, but then this is saying memory.size. Let me just understand what is going wrong there. Yeah, I mean, I thought I'd implemented this though. Maybe not. I mean, oh, maybe it was memory.grow that I'm thinking of. Yeah. Okay. Yeah, we've got memory grow. We don't have memory size. Okay. All right. Yeah, I was just remembering something different. Okay. Well, that seems like a different problem. I don't really know why this says memory.wast says needs load n and store n. Maybe. No, I just don't know why it says that. I mean, it clearly does need those. So, but yeah, maybe I decided that just by looking at it. But I think it's more important that it has memory.size. Anyway, okay. Well, let's just focus on load n and store n for the moment then. So I will add load to my test. And this is add load.wast to pending tests. So is this the first one? Yes, failed successfully. What I was going to ask was, is this the first one that uses signed? And it does look like it might be. So at the moment, the fact that we're just silently ignoring that is not really working, is it? So I probably don't need to investigate this very much. All I need to do is understand what it's supposed to do and then make it do that. And then hopefully this test is going to pass. So just think about this. So I think, so what does this do? Ultimately, this is going to return a 32-bit integer, and it's called load8 signed. So I think, i32.load is just saying load a 32-bit integer. But it seems that you're able to specify, I think there's load 16 as well. So you can say, you still get a, these all seem to be in places that are going to go wrong, but I think the idea is you still get a 32-bit integer. It's just that it's well, what does it mean? Because there's going to be some kind of offset here. So is the idea, I think maybe the memory contents were little endian, is that right? So if you give an address and you say, I just want to load an 8-bit number from this address, then it's only going to read 1 byte, which is the least significant byte, which is the only byte. and then it's going to give you a 32-bit number that's like 0 padded. The first 3 bytes are going to be zeros, and then the last one is going to be the byte that it read. So it's essentially like, you know, and if you do load 16, I assume what it does is it reads the least significant and then the next least significant byte, and then it splats those into the correct place in the correct place in the 32-bit integer. So I don't know how much of that work I've already done, and I can't really remember. So I mean, unfortunately, I think the answer might be none. Just looking at this. So what's offset? Oh. So there can be, that's not used here. So presumably I am paying attention to this offset. Yeah, if there's a static offset that gets added. Okay, right. So that's like an immediate argument in the instructions. Well, in the S expression, this is like this is like a static operand of this instruction. And we store that, but it looks like we completely ignore. So all that stuff I was just saying about how does load 8 work, there is no load 16 actually, or at least I haven't been. Let's have a look. Load 8. Yeah, okay, there is a load 16, but you have to specify whether you want it to be signed or unsigned. So yeah, at the moment we completely ignore the 8 and the 16 here. Somehow, until now, you know, I've clearly only added these because they were required by some test, but then that test has not actually cared about the fact that, and I suppose this makes sense, that you know, if what we were expecting was to specifically read the first byte from memory, and so we said load 8, or like, I guess store 8, like the implementation overlaps, right? It's just how many bytes does it actually modify in memory, or how many bytes does it actually populate in the result, depending on whether it's a store or a load. And it's not very difficult to imagine tests where it can't tell the difference between these two things, because, you know, the instruction said store 8. It actually stores 32 bits rather than just 8 bits, but then the test doesn't check to make sure that, you know, that the subsequent 3 bytes weren't overwritten by that store. And so I think that's why I've got away with it until now. But clearly we're going to have to start paying attention to this. So there are 2 pieces of information that we need from the operation. And one of them is, does it have a number in it? And the other one is, does it have an underscore suffix? Only load can have that. So maybe I should I separate these out? Well, they both have that offset. Yeah, the problem is this constructor is not going to be the same. For now, I'll just do a nested case here. Case operation in load or load 8s, and then in store or store 8 or store 16, because I know that these constructors are going to have to deviate. because store doesn't have this sign. Oh, well, look, we don't. This hash is not particularly useful anymore, is it? Yeah, I sort of ignored the contents of that hash, but it is actually important. Okay. So I mean, this is essentially a no-op, and perhaps that's a commit. I'll run the test just in case it's a commit. But really, what I'm concerned about is just thinking about what to call these things. And actually, good night. Thank you for joining, and thank you for your encouraging, kind words. I really appreciate that. Good night. So the reason I'm pausing here is that I realize that in the case of binary and unary operations, so they have a similar kind of structure, right? They've got this kind of underscore u underscore s, and I've just sort of swept that under the rug by just storing the operation name. So I wonder whether maybe I should do the same thing here rather than go in the direction that I'm going in here. You know, this binary op stores the type and the bits and the operation. Maybe I should store the operation, you know, I've got enough to know that it's a load or a store. I mean, I'm not very comfortable with the fact that this is what I do. You know, it sort of feels like it's, you know, it's sort of part of the job of parsing to do this. Let's see if any of this. I guess I shouldn't. This is maybe a little bit of sort of broken windows that, like, I suppose the reason why I threw my hands up and just gave up here is because there's so much variation in the sort of metadata that can be in here. So, you know, with truncation, for example, you've got all this business around, like, is it saturating? Is it signed? Is it unsigned? I just didn't want to deal with it. I've just smushed it. I've just left it in a string and just wanged that string into this single, like, unary op. Whereas obviously what I could have done here is, and maybe this is something to do later, is to break down this unary op into, like, at the very least, maybe there could be a truncate instruction, and then the parser will parse out all of the various, you know, it knows all of these different instruction names and it sets members of the truncate node correctly. So maybe that's something I should think about. So yeah, I guess what I'm going to do is I think I will keep pushing it in this direction, given that it is straightforward to do it in this case, rather than pushing that work into the interpreter. Like, if it's easy, I feel like I should do it here. But yes, that doesn't answer the question of what should I call. So this it says WW. Oh, sorry, those are like potential widths. Oh yeah, and I haven't thought about the alignment either. This doesn't seem to test offset and align. So that's okay. A memory is active with load and store instructions for the different number types. They all take a memory immediate memarg that contains an address offset and the expected alignment. Right, those are optional. Integer loads and stores can optionally specify a storage size that is smaller than the bit width of the respective value. In the case of loads, a sign extension mode is then required to select appropriate behavior. So SX is either U or S. So this does tell me the names of things. There's storage size and there's sign extension mode. Wow. So that suggests that we have a sort of storage size, sign extension mode to populate here. So why don't I commit this now and just say call the load and store constructors separately in parse numeric instruction. We need to add more arguments to the load constructor to properly support instructions like, what is it, load AS. So we can't share reuse the code that calls the store constructor anymore. So we can't share. Yeah, that's fine. And then yeah, that, like, ultimately we want that. So what do these instructions look like? I was just looking at them, wasn't I? So syntactically, so what I'm thinking about here is, can I just look for a number? And I think the answer is yes. And I wonder whether there's sort of, is there a regularity benefit in saying if there's a number there, then we store that as the storage size. If there isn't a number there, then we just reuse, you know, the native type. So if it was i32.load, then we would say the storage size is 32, and then we can just reuse the same code in the interpreter. It always gets a storage size and then it just figures it out. That's quite tempting, rather than having a special case that says, oh, if the storage size is nil, then use this type. So I think I probably will do that. I know there's code in the interpreter that does this. Yeah, it's this thing, isn't it? like slice. Yeah, how do I deal with this? Operation end with. Yeah, I've got to think about how to. I've got to think about how to represent. I've already forgotten the elaborate name they gave that. The sign extension mode. Like I think reusing some of this is probably fine. So this is something like storage size. What happens? So that's fine. What happens if there is no 8? Okay, I get nil. Okay, I'm just trying to think what's the neatest way to kind of have a default here. Well, I'm just going to do the simplest thing possible. So like, if storage size is nil, then it's just going to be bits. Else, it's going to be storage size 2i10. I mean, I don't love that. I could use then. I suppose that's fine. So I'm sort of defaulting it to bits basically. But we have to make sure that we convert it to an integer at the right time. And then this signed input thing, I think I want to do something like signed extension mode. Sorry, sign extension mode. Would have been quicker to type it. Is if it ends with S, then I'm going to say signed, else I'm going to say unsigned. Like, I'm taking unsigned as the default there because, well, it really doesn't matter. Because it doesn't affect the semantics of the instruction if the storage size is the same as the sort of native instruction size. But I think unsigned is sort of a more sensible default, because that's sort of our native representation, is that we assume that everything's unsigned unless you do this special thing. But I guess the question is, should this just be a Boolean? Should I just call it signed? I think maybe that makes more sense, actually. What was it originally called? Oh, signed input, yeah. mean, that's not reusing the nomenclature from the I can't decide. I do kind of like the idea of having a richer AST that, you know, the fact that there are 2 sign extension modes is, you know, what if there was a third one? There isn't a third one, though. I suppose what I'm saying is, it's not necessarily the case that in every situation where you're choosing between 2 things, that a Boolean is like the natural representation of those 2 things. Like, we don't intend to privilege either of these, really. It is just 2 different modes that this instruction can be in. So actually, I think I am just going to leave it as sign extension mode, and maybe I'll change my mind about that later, but for now that seems like okay. And then wherever load is here, it needs to have storage size and sign extension mode. So I'm hoping that everything still works. Seems okay, doesn't it? He says, before the tests have got to any of the tests that would actually use that instruction. Okay, test failed successfully. Okay. So what did I do here? I think what I did was this. It's like extract storage size and sign extension mode from load operation name. And then I can link to this. So load instructions, e.g. load 8, wow, i32.load, i32.load 8s. Let's have another example. i64 load 32u can contain a storage size and assign extension mode for use in cases where the value to be loaded is less wide than the result type. At the moment, we're completely ignoring this, but we need to parse it out of the operation name and store it in the AST. We'll do the latter part in the next commit. But it obviously affects the behavior of the instruction. Okay. And then so this is store load instruction, storage size, and sign extension mode in load instruction AST node. Store storage size. Yeah, that's fine. Not very beautiful. In fact, I would like to go back and reword this one, because I did make a decision here about not using a Boolean. I considered using a Boolean, e.g. signed, instead of a symbolic sign extension mode. But ultimately, it didn't feel as though I had a good reason beyond there are two options to use a Boolean for this. Neither mode is more important than the other. They're just two different modes of operation for the instruction. Ultimately, it felt clearer and more obvious to have an explicit sign extension mode member for the AST node. Okay. Not using that anymore. Oh, that's old. Okay. All right. Yeah, I didn't want to see a stash in my in this list of commits, so I think I'm good. Okay. So I think we're now in a position to be able to do something with these in the interpreter, right? So now that we've parsed them out successfully, we can think about what we want to do with them. So there's now going to be storage size, sign extension mode here. I mean, ultimately, it looks like memory.load is going to have to deal with this, isn't it? Storage size, sign extension mode. Oh, okay. So this is interesting because I'm not sure that we care about bits at all here. Like, bits tells you well, what does it tell you? It feels like storage size is the role that bits is playing here, that like, yeah, it defaults to 32 or 64 or whatever. I mean, this doesn't even pay attention to what the type is. Like, I don't think we thought about what happens when you load a float. But yeah, I mean, unsurprisingly to me, we don't have the same concept for floats. Like you can't you can't say I want to load a, yeah, there's just no, you don't have, that concept doesn't exist for floats. So maybe it doesn't matter. Like for floats, we are literally just reading or writing the bytes from memory, and it's exactly the number of bytes that the instruction type would expect you to read and write. So actually, I think maybe this storage size doesn't need to be here. I think possibly instead of passing bits here, instead of passing storage size, we could just pass it as bits. And then this is effectively ignored. Which does kind of make you wonder what the point of the bits is there. Well, validation is the point. You know, we need to know the overall type of this, but we're not using it here. So I think, yeah, it's questionable having these, you know, we really don't need to project these out in this pattern match. But I suppose what I've done is I've just put the signature of the AST node here. So I think I'll stick with that for now. But the reality is that we don't use bits anymore. We just use the storage size, which defaults to whatever bits was if it wasn't otherwise provided. But does that do the right thing? Like if I said I just wanted to load 8 bits, it would say size of bits in bits per byte. So that would be like 1 byte. And then it's going to get the byte offset 0. It's going to, this is doing the right thing. So it's going to not left shift it at all because it's the least significant byte, and then it's just going to bitwise all that with 0. Yeah. So I think that's going to work okay. The only thing that's not working okay is the sign extension mode. And unfortunately, the very first occurrence of this was in that, I think it was signed. Yeah, load 8 signed. So what does that mean? It means that we have to do essentially it means if what we've read is, you know, the number -5, if this is load 8 and we've read a single byte from memory that is the 2's complement representation of -5, then what we need to return here is the 32-bit 2's complement representation of -5, which is obviously not just 24 zeros and then the 8-bit 2's complement representation of -5. Like we need the sign, we need the top bit to be set, etc. There need to be lots of ones. So the reason I'm pausing is that I feel like I've already implemented that somewhere else. Because there are those sort of what are they called? Not extension. I can't remember what they're called. It felt like there were already some instructions that do something like this, but I cannot remember their name. See all the sort of bitwise instructions and stuff like that. Maybe I'm thinking of the floats, because with floats they do have these extension functions. Oh no, hold on, these are integers. What was I don't know. I don't know what I was thinking of. But yeah, this I64 extend I32S and I64 extend I32U, that is doing essentially what I just said, is that it takes a 32-bit integer that's signed and then re-expresses that as a 64-bit integer that's signed. So let's just have a look at the implementation of extend. Right, you just have to run it through. So where's this extend 8? Oh, down here. Yeah, okay, so this is exactly what I'm talking about. Extend 8s and extend 16s are what I need. So it's just the same code. And I suppose the point is that for unsigned, like extend I32U, yeah, that doesn't do anything. So it's only, you know, if this had been a Boolean, it's like only if the Boolean is true do we actually have to do anything. But that's okay. So this is like then do result. So this is like if sign extension mode. Ah, crap. Yeah, so we do need to know bits here, don't we? In this specific case. So this is case sign extension mode. So it's like in unsigned, it's just a result. But in signed, it's more complicated. Because we need to do this extending business. So I think this is going to need to be, this is going to need to explicitly be storage size. Yeah, so I didn't think this through properly. Obviously, when bits and storage size are different, if we've got an if we've got a signed number, then we're going to have to pad it out to the correct length in order to make it a cromulent signed number of that many bits. So we need to know how many bits it is. So before I forget that, let's just undo this bit of violence here. So we do need to know both. So here it's just going to be take the signed interpretation. Well, let's make this value. So let's take the signed interpretation of the value at on. Hold on, I don't want to screw this up. This doesn't actually explain what the extend instructions do. I think it is in execution. No, I think this is correct. I just wasn't thinking about it properly, but I think this is right. So, yeah. It's a little bit, it's been a while since I worked on this, so I sort of forgot what these signed and unsigned functions do. But what signed does, I mean, obviously, what we're going to get out of this is just a positive number, right? Because we're just reading bytes and we're ORing them together. And so we're going to get some kind of positive number. Now, if we know that it was supposed to be signed, what this signed method does is it will interpret this positive value as a signed, as a sort of a 2's complement signed value. So we're going to get back something which may be negative or positive. But in order to do that, we need to know what the storage size of it is. So this will give us back a Ruby integer that may be positive or negative, and then we're going to re-encode that effectively as an n-bit unsigned number, which essentially entails making it much larger. Yeah. I think this is right. I mean, I know I don't sound very confident of what the hell's going on here, but I think this is right. It's, yeah, mainly that I just forgotten what these signed and unsigned methods were actually doing, but we're sort of translating our sort of ground representation of values is unsigned integers. And so this is temporarily interpreting that unsigned integer as a signed Ruby, signed number, just by subtracting the sort of the size of the, whatever the bit width of this number is. Well, yeah, first we mask it off to be safe. And then, yeah, if it's in the top half of the possible magnitude range, we sort of translate it down into the negative half. So we're sort of remapping the top half of the magnitude range below 0. And then we do the opposite thing when we translate back into unsigned. I didn't really need to remember any of that. If I had a type system that was keeping track of all of this stuff, I would just know that composing these functions together gives me a result of the right type, but I don't, so I do have to waffle about it a little bit. So I'm sort of interested to see what happens now, because I have changed the behavior of that. Oh, and actually I've made a syntax error, so let's not waste anyone's time. Oh no, I haven't. That's supposed to look like that. Sorry. I thought I'd messed this up, but actually we're meant to be reassigning that offset. I guess because we get a dynamic offset here, which I've decided to call offset. Okay, I renamed it. It's no longer called result, it's called value. Oh dear. I got over enthusiastic with the water. I've made a big mess. Just pretend that didn't happen. Give me some dignity. As long as there's not a video of that happening on the internet forever, I'll be fine. What? Why doesn't signed work? No method error. Oh yeah. Okay. Well, that's fair enough because these methods aren't available. Okay, well then that raises the question of, do I need to even do this in memory load? And I think the answer to that is no. This can all happen outside, can't it? Like my instinct was, oh great, I'll better make those methods available inside memory, but actually memory doesn't have to care about this, does it? And in fact, I don't know why I decided to make it memory's problem in the first place. It can all be taken care of inside here. So let's leave this nice and agnostic. This is just, and this makes more sense. I'm sorry, I don't know why I jumped to doing this, and it's actually kind of nice that I've been slapped on the wrist by trying to call methods that aren't available on this memory class, because actually there's no reason why memory should have to care about this. However, this instruction should have to care about it, but this is exactly the sort of place where I should be able to call signed and unsigned and stuff like that. So so what that means is we are gonna ask the memory for the number of bits according to the storage size, not according to the bits of the result. And then we're going to say if sign extension mode is equal to signed, well, no, let's do this. I don't really like the idea of only checking one of the two possible values here. I like the idea of having this sort of, because the pattern match is going to be sort of exhaustive here. Oh no, that's worse. Sorry, I was getting distracted by indentation. Because there are only two possible values of sign extension mode, I kind of like the idea of having this pattern match kind of check both of them, and then making it clear that if it's unsigned, we just return the original value, and if it's signed, then we do this little manipulation where we do actually care about the bits. So I think perhaps that's, well, why don't I just run the test that I'm wow. I was not expecting that. Okay, cool. Great. So, I mean, whether this is the nicest way of doing it, I don't know. I mean, this is a little bit of a mess, isn't it? But that's actually quite cool that that works. Error pending test passed. Cool beans. Okay, so what are my changes here? I mean, this is pretty much it, isn't it? I think this is a self-contained change. Use storage size and sign extension mode when interpreting load instructions. We only need to ask the memory for storage size bits and then convert it to a signed number of the appropriate width if the sign extension mode indicates that's necessary. Cool. So what about store? Like, have we even tried to run that? Oh, is that already? Oh yeah, that's already passing. Okay. Because, you know, ultimately, we should probably heed the storage size for store instructions, but apparently we don't yet have a yet have a test that requires that, so fine. So we've done that one. And I've got load.wast passing. I think I'm going to need to implement memory.size for memory.wast. I mean, I haven't implemented store_n. Well, that's another test passing, so I'm pleased about that. How likely does it seem that I'm going to be able to pass this test? So it makes a bunch of memories. It's calling memory.size a bunch of times. I need to just implement that. It seems like something I could have sworn I'd already implemented this, but I mean, yeah, memory's got this size in pages. Who calls that? Oh, right. Yeah, memory grow pushes the old memory size onto the stack. So I kind of have already implemented that. You know, I could just grow by 0 pages. But I won't do it that way. Well, that's probably quite easy to do then. What else? Load AS. Oh, these are all assert invalids, which I haven't implemented yet. What's this doing? So this looks like this is doing some quite gnarly loading unsigned values. So this is going to exercise the storage size parameter. See, look, I haven't implemented alignment yet. I think this is probably achievable though. Like, I don't see anything here that makes me really worried. I'm assuming that these tests are going to notice that I haven't implemented store 16 and store 8 correctly. That's fine. I know how to do that. And the parser isn't going to be able to parse the align here, but that's fine. I know how to do that. So actually, I think this is all within reach. So I think I am going to, effectively what I'm trying to decide is if I want to commit to putting this in my pending tests, but I think I do. Because this is all, yeah, this all looks semi-approachable, basically. Okay. Yeah, parsing problem, memory.size. Okay, we're going to need an AST node. And the AST parser that currently parses memory.grow is also going to need to parse memory.size. And here we'll just memory.size. So that will fix that problem with the parser, but now the align. Oh, what? Undefined method force encoding for nil. What the what? Oh, parse string is having some kind of problem. What kind of problem is that having? Parsing double quotes. So is that this? Do I just have a problem where I can't handle the empty string? Okay, so what goes wrong here? So string equals that. Encoding equals string encoding. That's fine. So what happens when we... Okay, so now it literally is the empty string. We force its encoding to be ASCII 8-bit. Why did we do that? Oh yeah, because of this. Ugh. Yeah, because of this. So this is to do with hex escapes. Damn. I didn't do a good job there, did I? Right, so why is that returning nil? Under what circumstances does gsub return nil? Is it if the block raises an exception? No. Okay. Oh. Return self if any replacement occurred, nil otherwise. So how has this ever worked? This is literally the first time I've tried to parse a string that doesn't have an escape in it. That's ridiculous. Well, I'm just going to get rid of that exclamation mark, I'm sorry. Because that's silly. Data, no matching pattern error. Oh. Hold on. What? So we do the empty string. We do X. Is this getting bogged down in the assert invalid, or is it here? Is it because... Oh, I mean, I just don't know, do I? I don't know where this is going wrong. Okay, well, I don't need this anymore. Where is this exploding? It is inside build initial context, read list. Okay. Let's just see what comes out. Reading list from data I32 const 20. So is that the earliest occurrence of that? It should be ignoring the assert invalid, I hope. I guess the parser probably isn't. Oh, but maybe it is actually. Yeah, I guess it is. I guess it is. Because it just throws away all of the contents of insert invalid. It doesn't try to recursively parse the content of it. So it's getting down to this one, and it's complaining that it doesn't know what to do. So build initial context, repeatedly read list do. So it's looking for things like func memory table global type, and it doesn't know what to do. Again, it's astonishing that this hasn't been a problem up until now, but it doesn't know what to do when there's a memory. No, when there's a data segment here. I mean, is this not something that we've previously implemented? Is this like syntactic sugar for a different thing? Data segments. I mean, I thought yeah, I thought we'd seen this before. Data segments allow for an optional memory index to identify the memory to initialize. This data is written as a string, which may be split up into a possibly empty sequence of individual string literals. And I guess the offset here is this I32 const 0. I wasn't expecting this to be difficult, but it sort of is. Because I think this is going to be a problem. If we've never seen this before, which must be the case, then it's going to be a problem for parse text fields as well. You know, there's nothing here to support parsing data segments. So, yeah, maybe I need to think more carefully about my current implementation of this, because we definitely can parse this like straightforward, you know, parse memory data. It just reads data and then it reads multiple strings. So we can support that, but we don't have any support for this offset, which I guess is optional. Yeah. And I don't know what this mem use is. I assume this ID, do you have to give it a name? This isn't giving it a name. Yeah, as another abbreviation, data segments may also be specified in line with memory definitions. So I guess that's what I've seen previously, is a data segment can be given in line with a memory definition, in which case its offset is 0. And yeah, so this is what I've been doing so far. But apparently this data can also appear at the top level, and this is actually just syntactic sugar for it appearing at the top level, with an offset of 0 and so on. And it looks like with the data segment, you're supposed to specify which memory it lives in. So you're supposed to say, like, this memory has got a symbolic identifier, and the data lives in the memory with that symbolic identifier. But semi-worryingly, this doesn't have an identifier, so how does that work syntactically? Data segments allow for an optional memory index to identify the memory to initialize. Oh, is that a question mark? Okay, yeah, it is. Okay, so the ID is optional. You can have multiple string literals, which we've already dealt with. What's a mem use? Oh, it's this. Right. What? Oh, right. So the data itself can have an ID? Okay. I mean, we're not seeing that here, so I guess I don't have to worry about that yet, but apparently the data can have an ID. And then it's got this optional memuse that specifies which memory. I don't understand. This doesn't look optional. Oh, right, a memory use can be omitted defaulting to 0. So epsilon is an abbreviation for memory 0. So okay, even though the grammar here doesn't make it optional, you can simply include the empty string at the right place, and that will be expanded to say that you're referring to memory 0. Okay, I think I understand all that. So, all right, we've got a more serious problem here, which is that we need to support data segments properly, which I didn't realize when I decided to get into this. So what can I might as well commit this stuff that I've already got, because I think this is all okay. Add memory size AST node and support it in the parser. It's not very interesting, but that needs to be done. Let's say use gsub instead of gsub in parse string. The latter method returns nil if no substitutions occur, which makes me confused about how this was ever working. Maybe we've never tried to parse a string literal that doesn't contain any hex escapes before. Anyway. Who cares? Okay, so now I've got to think about this parse memory data is unfortunately a little bit more complicated. No. I think I'm just going to do it separately for now. I'm thinking about like how can I share code with this when I'm trying to read something that's syntactically quite different. And I think the answer is just going to have to be I'm not going to share it at the moment, because I just want to get this file to parse to something. In the limit, I'm going to need to support all of these features inside the abbreviation. So when this appears in line inside memory, and I think that's going to really, this whole edifice is going to crumble because I can't just provide a string here. I need to, well, really what I need to do is create a separate data segment, which is a little bit painful, but I will, like I say, I'll deal with that separately, I think. You know, fortunately this is called parse memory data, so they can just be parse data. So let's just chase the failures, because at the moment it's the fact that it doesn't know what to do. When it's creating the initial context, where is the information about the initial context? Maybe it's in modules. That would make sense, wouldn't it? Oh yeah, we're supposed to be collecting all of the data IDs as well, apparently. For now, I'm gonna just ignore that. Oh, what's it called? Oh yeah, build initial context. Okay. Func memory. Oh, I haven't put these in quite the same order. Well, or indeed even vaguely the same order, but I'll just add this at the bottom then. So if we find data, then it's a similar deal to this, right? Ultimately, this is a to-do. We should be remembering the IDs of all of these datas in the identifier context, but I am not going to do that. So hopefully this is going to give us a different error. Parse text fields, yeah, same deal. I suppose I'll parse data. So let's do it here. So this is ultimately going to need to return some kind of AST node, I think. Oh. We can't call it data, can we? That's a shame. Well, I could, of course. But it would need to clearly be in this namespace. Oh. Do I want to go through and prefix all of these with double colon? No. Let's call it memory data for now. And then I can regret that later. Okay, well that's obviously not going to work. Yeah, okay. I shouldn't be trying to parse string, that's not right. But I can probably do that. Parse numeric instruction, load AU, no matching pattern error. Okay. So now we need to support load 8u here. I assume there's going to be a bunch of these. Because this file is going to exercise all of them. Okay, and then we've got the align problem. So we're going to have to repeat this. Align. I don't know that there's any requirement that these are in this specific order. So this is really just hacking. Oops. I'm just trying to get to the point where the parser sort of finishes. Load 16s is the problem now. I mean, maybe here I should be asking, like, if operations start with load. I regret that now. Load 16u. At the very least, I can give Vim a fighting chance here. Store 32. We must be reaching the end of the list of things that we have to support here. Load 32s. I spoke too soon. And almost certainly we're going to need a load 32u as well if this test is exhaustive. Yep, there we go. Hey, okay, that's what I wanted. Okay, so I think I am gonna commit this. Oh, actually. So this is just going to be ignore data. Well, let's just say ignore data segments in build initial context. Eventually, we'll need to populate the context with the data segment IDs, but that's not required for the test. For the test we're currently trying to get parsing, i.e., what is it? Memory.last. Okay. So for this, I think I will do So this is going to be like add dummy AST node for data segments, and what did I say? Add dummy AST node for data segments and support it in the parser. It's going to need, well, the interpreter is going to need more information than this, but I'm just trying to get memory.wast successfully parsed before anything else. Okay, and then I think all the rest of this is, yeah, I should probably, I think I can just put all this in one change. So this is sort of support parsing the remaining load n, store n instructions. We still aren't doing anything about the storage size for store n instructions, but we'll probably need to fix that soon. And then this is just, what was the other one called? Offset. Okay, add support for alignment in star.load instructions. Let's see what the syntax actually says. Memory instructions. Oh no, the offset does have to come before the alignment. Okay. Says that the offset if present has to come before the alignment, so we don't need to do anything more sophisticated than attempts to parse them in this order. Okay, I mean there's obviously some duplication here. I'll fix that later, probably. Let's say leisurely parser refactoring. Extract a helper for parsing offset equals and align equals. What did I call them? I can't remember what I called them. Okay. So that's all. Working tree is clean. Oh, it doesn't know how to evaluate memory size. Okay. Well, I can help you with that. I think it's just that. Cool. Well, 3 assertions passed, which is an improvement over where we were at previously. Well, first we couldn't even parse it, and then this was failing, but now those... So we know that memory size is working correctly, which I guess we already knew because memory grow was doing basically the same thing, but that's still good. Implement memory size. What do I normally say? Oh yeah, okay. Well, let's just say implement the memory.size instruction. What does this commit look like? Yeah, that's fine. Easy. Okay. But now we've got to actually do some real work. Assert return. I mean, it's the very next one, I think. Invoke data. Expected 1 got 0. So what's going on here? What's the data function? Oh, it's this thing. Okay. All right. Well, this is only going to work. So this is... This is writing this string at offset 0 in this memory. And then this is writing this string at offset 20 in this memory. And then all of this is loading various bytes out of that memory and anding them together. And apparently the result is supposed to be 1. But unfortunately it's 0 because this instruction is just being ignored. So I think I'm going to continue with my approach of really just only supporting what I need to support. So here, this is actually the only standalone data segment in the whole test. So, well, there are 2 of them, but they're of the same form. So as long as I can support this, I'm going to be fine. So let's support that then. Modules, data segments. So I'm going to support this form where the offset is actually an instruction. Just trying to like understand what the point of this is. But I suppose it's so that you can, so that the instruction can be I32 const basically. But I guess it can be arbitrarily complicated given that it could be a folded instruction. Or, you know, it doesn't have to be folded, does it? It could be a block instruction. A structured instruction is what I'm trying to say. So yeah, this isn't necessarily trivial, but it is in this case. So what do I want to do here? Let's see if I can enrich. Oh yeah, we need to be in the parser. So this is just repeatedly read. I think we want to end with repeatedly parse string join. And here I want to read a list and I want to parse an instruction. I mean, it definitely seems like something I should be able to do. Yeah. If it's a numeric opcode, then do this. Oh, actually, so I don't think it can be folded. Oh, no, I guess it... I guess it could be. Yeah, it could be. It would just require another level of brackets. Is that right? I don't know what I'm talking about. I haven't thought about this properly. I actually don't know if a folded instruction can appear there, but I think it probably can, because the set of all phrases defined by the following abbreviations recursively forms the auxiliary syntactic class folded instruction. Such a folded instruction can appear anywhere a regular instruction can. So yeah, I mean, you would have to put another set of brackets around it. I'm just going to leave it. I'm just going to leave this for now and make it, and not worry about it. I think this is going to, right, that still allows me to parse it. So yeah, in the spirit of this isn't a problem yet, I'm just going to ignore that. So what is this? The offset? Yes. So that's the offset. This is the string. And then I think we should do that. And at the moment, I'm not even trying to parse what memory it's referring to. So at the moment, I'm only going to be able to support this sort of implicitly referring to the first one. Offset string. Does that work? Yes. Okay. So now what? What happens when I parse that? Oh, I want to actually add it to the data segments, right? Yeah, what does parse type even do here? I guess we just throw it away. So this needs to be datas. So we're accumulating that. Maybe I'll put datas here. No, I've already decided to put it there. I'll put it there. It doesn't matter, does it? Oh, I only support one memory at the moment anyway, so that's not going to be a problem. Okay, so that's gonna... Yeah, we don't even have an object to represent this at the moment. Parse text fields just returns a hash. Oh, and then right, they get passed into the constructor of module. So module is going to need datas. Just see what the structure of a module is. Types, functions, tables. Memories, globals, LMs, datas. Yeah, okay, this is all just a big mess. I'm not obeying that or anything. Okay, so that's good. That's still threading through into the module constructor. So we're now remembering all of those. So maybe that's an easy thing for me to add, actually. Yes. 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 So even before we've got any rich data on those data objects, at least we're storing them in the module. So this will say store module data instances. Store module data. Store data segments on module AST nodes. And then what's this? Store offset and string on data segment AST nodes, I think. Yes. Okay, so that still doesn't do us any good. I'm just trying to think about when. I guess it's during the initialization of the memory, isn't it? Like, there's something in here when we start evaluating the script and we've got the module and, you know, this thing has got datas. I suppose what we can say here is that sorry, I'm not being very articulate. I'm just sort of thinking about what we need to be able to support in terms of like what happens if you don't specify a memory. Then do you get one anyway? It doesn't say anything about that. So I think if you want to give a data segment, you have to have declared a memory, or you have to have imported one or whatever. So I think for the purposes of this test, oh, the only valid memory index is 0. Okay. So I think, I mean, this is a bit of a bodge, but I think what I'm going to do is say, like, if the memory is initialized, then we're going to iterate over the datas. And write their strings into the memory. So I want to say memory.store value offset bits. Oh no. Because the offset is something that we have to evaluate. Oh, and how many bits? Hold on. Is this... Yeah, this isn't quite the right... I'm going to need to... Yeah, I mean, this kind of from string is kind of what I want, but I think I'm going to ultimately just need to call store a bunch of times, which is a bit annoying, to store the individual bytes out of the string. But that's okay. Okay, so let's think about this. So the steps are going to be evaluate the offset, because offset is actually an expression. Iterate over the bytes from the string. Write each byte into the memory at the correct address. Okay, so I think, assuming that I've got an offset there, then I think I can do something like is there an each byte on string? Yeah. Yes. So I want to do data string each byte with index, do byte index. Memory.store value, well, this can be value. Offset can be offset plus index. Bits is bits per byte. I don't know if I'm allowed to refer to that, but that's what I'm going to go with. So that is those two to-dos, I think. So I'm basically just sort of evaluating those, I guess, as part of the sort of module initialization. I do have this evaluate expression. So So this could be data.offset. Oh, it's actually just an instruction, isn't it? So it's not an expression. And then this is going to give me my offset. I think that's right. So you evaluate the instruction. The assumption is that's going to leave a single value on the stack. I mean, it doesn't say this. I'm sure there's something in here. About, I suppose, instantiation is probably when data segments. Let bytes be the vector of bytes to allocate first free data address. Okay, yeah. So this is instantiation. What I'm doing here, and I just didn't know that that's what it was. Well, there's nothing useful there. I think this is correct. Oh my word. That's amazing. Well, it's particularly surprising because I'm glad that all of these load instructions work correctly, but what about stores? Oh, it doesn't test that. I already established that. But I guess this is a vindication of all of my load implementation. But it's just very strange that it's not exercising the storage size for the store instructions. And also, we're just completely ignoring this alignment. Very strange. And worrying. I mean, I guess these are all operating with this like align equals 1. And maybe if you change all of these to align equals 0, then they all still work the same way. But that seems like a bit of an oversight as far as the test is concerned, because it's really not exercising that align at all. I'm just parsing it and ignoring it. But okay, let's run all the tests. Oh. Oh, crap. Okay, what's happened here? Because I've broken this at some earlier point. Which is not bad, which is not good. I would say it's bad. Yes, please. Okay. Not restore, but switch. I mean, I pretty much know when I broke that, but I'm just confused about how. Okay, this is the first bad commit. So is there some other place that I'm instantiating modules? I guess. It's this one, isn't it? Stupid. Datas. Okay, so that's going to be fine now. Okay. Okay. All right, so I think disaster averted. Yes. And now let's actually let it run. I mean, this is looking pretty hopeful. Oh, yeah, well, apart from that minor detail. Yeah, I mean, that's pretty good. I wasn't really expecting that to work. I mean, it feels like this is just a single change. Like, what did I decide it was called? Instantiation. So this is something like copy data segments into memory during module instantiation. Is that right? Yeah, I think so. Do I want to say anything about this? At the moment, we're assuming the data segments should be copied into the 0th memory. Which is naughty, but fine, since the spec says that 0 is the only valid memory index in the current version of WebAssembly. So it might be that I essentially never fix that problem, like until, you know, I mean, I guess it's a problem that the parser can't even successfully parse the index if it's present. Like, I am going to have to fix that, but there's very little incentive to ever store the index in the AST, given that it can only ever be the 0th one. So I mean, I guess this is sort of done. Like, it turns out those two didn't need it. So memory.wast is done. I mean, we're starting to... Well, I mean... Why does this say needs question marks? Exports. No matching pattern error. Well, I think it just needs export, doesn't it? It's not too mysterious. Yeah, I've sort of bottomed out on the things that... on the obvious things. Or not obvious, but the things that were to do with the stuff that I was previously working on. Like, this whole thing has been about trying to... Oh, look. I bet I could make this pass. I mean, I don't even know what that is, but it is a thing. Yeah, maybe I should be thinking about these sort of memory related ones. Binary. Oh no, God, we don't support that. What's address? Like, actually, a lot of these are memory tests in disguise. Yeah. 32 good 5 is failing. So there's something interesting there. What else? What other sort of memory themed stuff is there? Because if I could iron out those problems... Bulk. Oh, memory.fill I don't think I've implemented. Some kind of parsing error. There's something in here it just can't parse. A lot of these assertions I wouldn't assert trap and stuff I don't implement yet. Custom. Ugh, no. Oh, yeah, okay. data. Oh, sorry, we've already got that. So there's actually a ton of stuff that this, you know, it's not just all these things. I think we need to import spec test and things like that. So that's a little bit difficult. We haven't really thought about LM. Like, that just needs proper LM support, I think. Okay, I'm getting a little bit distracted. I was hoping for. Oh, Endianness. Could this already pass? Yes, indeed it does. And presumably, if I switch to before this session, I would expect this to not be passing. Yeah. Right, I couldn't even parse this because it didn't even know about the load 8u instruction. So that's pretty cool. Let's add that. Endianness. Did I spell that correctly? So let's say add endianness.wast to parsing tests. So what was the problem? So I can say our recent work on i32 etc. has made these tests pass. Great. Cool. I think I'm already doing conversions, aren't I? Yes. All the float stuff. Factorial, factorial. Does this work? Yes. I'll take it. What does this depend upon? Maybe it's just blocks and loops and stuff. Oh, it does depend on block parameters here. But it uses block types, so it wouldn't have worked before our recent work. But so it wouldn't have passed before our recent work on before the recent commits, which let's let's say, but it contains loops with block types, so it wouldn't have passed for the recent commit choice make. Which make loop parameters work correctly. So actually, I think this is actually a very recent win. I don't think this would have been passing again if I... Yeah. So that's cool. That is like a legitimate win for this session. That's not a coincidence. Let's forward. I mean, now I'm just hoping. But yeah, this one also is passing. Yeah, that was already passing. Yeah, so the only this file tests the ability for two functions to mutually reference each other's symbolic identifiers. So it's probably been passing since we implemented the two-pass processing for populating the initial identifier context in the AST parser. I'm not going to bother investigating that, but I think that's probably true. And I mean, maybe this would have worked already anyway, because we didn't try to dereference these identifiers until function invocation time, until we then went and used the identifier context to replace these with indexes. At least I hope that's what we're doing. That's now made me a little bit suspicious that I can't remember. Yeah, no, it doesn't do any looking up. It just uses the index. So I have, thank goodness, I have done that. Okay, so forward is passing. We must be testing func, or are we? No. But maybe this is testing something that we haven't implemented yet. No, func is passing too. This requires all sorts of... Have we really not tested this? No. Oh yeah, it's in there. What did I do wrong before? Oh, I typed gunk. All right. Well done me. Okay, never mind. What's func pointers? Does it just work, or is it something we haven't implemented yet? Yeah, something we haven't implemented yet. Import. Oh, it's just for spec test. Okay. So that's very annoying. Oh well, that's a shame, because I think perhaps without that this would have been fine, but whatever. That's probably more low-hanging fruit. Inline module. Oh yeah, we don't support that yet. It's like there's no module declaration here. There's sort of a default implicit one. Are we already doing labels? Yes. Fine. What's left to right? This is another memory related one. Expected 258 got 2. Okay, I mean, these ones where there's like a legit assertion failure, it's kind of tempting to try and fix them, right? Because they're, I mean, maybe this one, you know, I know that this is using instructions that we haven't implemented properly. So, I mean, what on earth is this? I mean, I suppose this is just doing some kind of exhaustive test of all of these instructions. But ultimately, we should be able to... I don't know why it's called left to right. Who knows what this is doing? But this all looks like stuff that we should be able to support. We reset the memory. These functions all called bump, which shifts the... Oh, okay. It should then contain the correct sequence of unique bytes if the calls are evaluated in the correct order. Okay. All right, well, that sounds like an interesting one to actually tackle. Linking, register. No, I don't know. I don't even know what that is. Oh, look, there is a memory size. So we've got float memory and memory. Presumably memory fill doesn't work because I don't think we've implemented that. No. But there is a memory grow. Oh. Okay, so that's failing. What about memory size? Also failing. It's a shame. It would have been nice to have that for free. What's names? We're already doing that. Names needs import. Oh, we've already got that. Okay. Already doing NOP? Yeah. That sounds like something that's more my speed. No, I don't know what register is. We already doing return? Yep. Select. No, that's just an unimplemented instruction. Oh, ref null func ref extern, this says. Yeah, okay. Fine, that's already there. Okay, Stack Overflow guard page. I think there's no chance of that working. Presumably store.wast. Oh, we're already running that. Yeah, so that, I was going to say, presumably that really exercises it, but it doesn't. We haven't done any of the table stuff. Token. Really doing that? Oh, apparently I don't have support for that. I'll leave that token for now because that's, I don't know what's going on with that. See, unwind. We should probably be able to at least try to run that. Yeah, wow. I guess that indicates that I've got stack unwinding working correctly. I mean, there's a few. Well, all of the ones that involve unreachable, I'm not running those assertions. But the ones that are there are passing. So let's add that. Let's just check. Oh yeah, it was already passing. This was already passing before the recent changes to stack unwinding. So maybe it's been working for ages. No. Or perhaps it's only the currently skipped assert trap assertions which are meaningful. Either way, we get it. Okay, all right. Well, that's... I've kind of stacked up a few more passing tests there, so I feel pretty good about that. Some of them I deserved. Some of them I didn't. But I'll take all of them. Okay, well, that's my bedtime, basically. So I should... Well, of course, before I do anything... just waiting for the test to run. Okay. Before I do anything, I should push these up to GitHub so we can see them pass. Tom Stewart. That's a me. Okay. So git push. Let's see this pass. And then next time I'll come back and I know that there's like refactoring work that needs doing, but it's just so much more interesting to tackle, these problems and try and get the instructions working correctly and then understand the spec and implement it. So I think I'm gonna, why is this telling me to sign up? I'm not logged into GitHub apparently. That's surprising. Okay, well, I'll fix that offline. So I do think I will come back and, for this left to right, for example, like maybe I can actually get that passing. Maybe for memory grow and memory size, I can actually get those passing. Like just kind of hammering out some more of the edge cases around here. I do need a refactoring here that is support parsing data segments both inside memory and standalone with the same code, i.e. support the memory abbreviation. Great. Perhaps by synthesizing the correct string for the memory during parsing. Great. Okay, well, apart from me not being logged into GitHub, that went very well. So I think that's probably it for now. I'm definitely getting quite sleepy, so this feels like a good place to stop. But that was pretty successful. Like I again, after taking a bit of a break, I wasn't quite sure how much of that was still going to be in my brain, but actually, I think if nothing else, it's confirmed that I now do sort of understand the way that branches and blocks and stack unwinding is supposed to work. And then, yeah, I think all those memory changes went pretty smoothly. I've had a lot worse. I've got a lot more test passing that time. So that's really good. So yeah, I've added, I think, what was it? Loop.wast, load, memory, endianness, fac, forward, and unwind. So that's 1, 2, 3, 4, 5, 6, 7 test files. And yeah, I didn't deserve all of those, but I chose to check to see if they worked. So 7 seems like a lot of test files to get passing in one stream. So yeah, I feel good about that. I feel like the new year is off to a good start. I've sort of started as I mean to go on. I've hit the ground running, various other cliches. And yeah, compared to what I thought might happen, which was that I sit here for 30 minutes staring at it, not making any progress, and then have to turn my webcam off in disgrace, that wasn't too bad. So yeah, I guess that's it. I'll say bye. And yeah, as always, thanks so much for watching. I really appreciate all the time and attention of those of you who have joined in the live chat or are watching it afterwards. Yeah, I'm always just extremely grateful that you can be bothered. So thanks very much. I don't know when the next one of these is going to be, but whenever it is, I'll see you then. Bye-bye.